This talk is sponsored by LivePeer. LivePeer is a decentralized video streaming network that provides the necessary infrastructure for broadcasting video over the internet at a fraction of the cost to today's cloud infrastructure. Learn more at livepeer.org.
Hi everybody, my name is Eric Tang and I'm the co-founder and CTO at LivePeer. Today I'm going to tell you a little bit about the Web3 video stack. This is a emerging kind of new technology stack that we've been all building for a long time and that we're very passionate and excited about. Hope that I can share a little bit of more information around this and also to share some more details about what can be accomplished with this new technology stack. A little bit about LivePeer before we dive in. LivePeer is building the video streaming layer of Web3. We've been around since 2017 and we've been working on this problem for a little while. The goal is for us to enable this new decentralized video streaming application and ecosystem. It's a developer-facing product, developer-facing network, an open source ecosystem, right? People can use LivePeer to build video applications. It's not exactly like YouTube or Twitch, but more like an infrastructure or developer tool that allows people to build like a Web3 version of YouTube or Twitch. So today, what we'll cover is, what is the Web3 video stack? Talk about some of the opportunities in the Web3 video stack, in Web3 video, and then I'll share a little bit about what are the developer tools that are available within the LivePeer ecosystem that can help you build a Web3 video application. So what is the Web3 video stack? On the high level, we think of the stack as a combination of technologies that are decentralized and in combination serve as all the different modules that you will need to build a Web3 video application, right? So we have kind of the smart contract layer, and we also have some of the decentralized Web3 infrastructure layer like storage, query, or streaming. Altogether, this is the combination that forms the Web3 video stack. Before we get into details of this, I think it's interesting to just take a quick look back at how we got here today, right? Even though online video is kind of all-consuming today, we can't make our day make through the day without consuming video online. Video online hasn't been around for that long, right? So let's dial the clock back a little bit. Back in 2005, which is merely just 17 years ago, there was a small dating application that was working on a video-based Hot or Not. Hot or Not was kind of maybe the first popular online dating application, right? These two founders were trying to build a video version of it. It was not very successful. Not a lot of people were using this application. So they decided to kind of ditch the dating idea and just focus on creating a website that allows people to upload videos. And they named this application YouTube, right? Very quickly after this pivot, YouTube started growing tremendously. They just within a short 18 months of time, it became the number 5 most popular website in the world. And throughout this time, it was oftentimes the fastest growing website on the internet, period. Right. And some interesting things about YouTube. YouTube has only actually been independent for about 2 years, right? Since the founding. Over that 2 years, raised about $11.5 million. It was burning about $2 million per month when it was being acquired. A large portion of that $2 million was going to kind of paying for the infrastructure bill. And it was acquired by Google back in 2006 for $1.65 billion. And Google, of course, at that time knew which website was growing the fastest. It knew that YouTube had this tremendous potential, and they were building an internal video application. It wasn't working out as well, so they acquired YouTube. Right? Coincidentally, a year after the acquisition in 2007, Google introduced this ad model where advertisements will be shown alongside of videos that people upload into YouTube, and there will be a rev share, right, which means the creators of those videos can potentially get a portion of that ad revenue, right? And it started this ad-supported model for online video streaming industry. Another interesting example, just quick 2 years after YouTube was started, there was another company called Justin TV that got started. And at the very beginning, Justin TV was an application that was kind of an online reality TV show, right? The founder of Justin TV attached a webcam on a baseball cap, and he would wear a backpack walking around 24/7, kind of filming his day and broadcasting it to the internet and as an experiment. And it was one of the first Y Combinator companies in the world. Unlike YouTube, Justin TV actually struggled in the first 4 years of its existence. Right, they had numerous legal troubles along the way. Lots of people were kind of streaming or uploading kind of copyrighted content, and that was a big issue. The CEO even had to go testify in front of Congress because they were being sued by a lot of these large companies. And so at the end of 4 years, given this kind of tumultuous path, Twitch, they noticed that there was an audience on their platform that was kind of niche, but had a growing trend, right? Which was people watching other people playing video games. At that time, people thought it was very strange, but nevertheless, they wanted to give this a try, so they actually spun out this niche on their website into its own company called Twitch. And of course, right after Twitch was spun out, this community was created. It started growing exponentially. They were very creator focused, right? Focused on the gamers themselves. They created the first application where a live video stream and a live chat can happen at the same time. So the broadcaster can kind of be responding to the live chat in real time. And they really didn't have any, they were able to kind of sidestep the content rights issues a little bit here and create kind of sticky long sessions because people were playing video games, for at least a couple hours, right? And just a quick 3 years after that, Twitch was acquired by Amazon in 2014 for $1 billion. At that time, this was the largest acquisition that Amazon had ever done, right? It took about 20% of the cash position on Amazon's balance sheet. And of course, the second place bidder that Amazon outbid it was Google, who was trying to buy Twitch as the kind of the live streaming product for their YouTube product line. Right? Another interesting example, Netflix. Right, we all know the name of this website. They started a little earlier, but as an online DVD rental business. Right, this back in 1997, where there wasn't really video streaming on the internet yet because it just wasn't the bandwidth wasn't as proliferated at the point. It was a pretty successful business, and went IPO in 2002. They always known kind of video streaming would have been another way to grow the company, but they never really launched a streaming service until 2007. Largely inspired by the success of YouTube, right? And of course, a short 3 years after launching their streaming service, that streaming business surpassed their DVD business in 2010. And Netflix, of course, famously started the streaming war, which is the idea of companies spending a large amount of budget buying and creating original content for their platform, right? So now Disney Plus, Apple TV, all these other streaming services are kind of spending just more and more money into content creation, right? Famously in 2021, Netflix spent $13.6 billion in buying content alone. And they account for about 19% of the bandwidth on the internet today. Some of the lessons that you kind of learned from this short 15, 17 years of history of of online video, right? Well, video is driven by creators, right? We look at all these video streaming websites. Well, they don't. These companies aren't really creating videos themselves, right? Even for the quote-unquote original content that Netflix is creating, most of that content is actually created by independent creators that then get pitched to the Netflix studio, and then the Netflix decides to purchase the rights to that content that then they'll stream on their distribution channel, right? So without creators, these applications would not be here and would not be as profitable as they are today, right? So creators, of course, they're now spending an enormous amount of money to court creators, but at the same time, these are large distribution channels that are able to really negotiate down the take rate, right? So YouTube famously has about a 50% take rate, which means for every $2 that are made on YouTube, usually through advertisement, YouTube takes $1, right? And the creator of the content takes another $1, right? And of course, this is on average. A lot of times, the long tail creators don't make anything. Right? Another thing to point out is YouTube, video is everywhere, right? We can see video is in all the entertainment platforms. Video is also education. Video is in all the e-commerce platforms. And video is in business and personal communication, right? In fact, about 80% of all the internet's traffic today is video. So as we can see, it's the predominant content format of the internet of today. Right? Another thing to point out is that video today is highly centralized. There are about 50 million content creators around the world, out of which about 2 million are professional content creators, which means that's their entire job. Right? If you look at all the content creators, they're spending most of their time on a very few number of platforms, and these platforms know that, right? So they hold all kinds of powers over the content creators. They build up a very arbitrary anti-competitive rules so that other people cannot compete. For example, Twitch famously say that if you want to be a Twitch partner, which means if you want to be able to make money streaming on Twitch, then you have to exclusively stream your content only on Twitch, and you cannot be streaming that at the same time to other platforms. If you get caught by that, you get kicked out of the partnership program, right? So all of these rules are not really good for creators and for content creators, right? And the content creators are realizing this, and as the rise of Web3 is coming, we're starting to see new Web3 video platforms that are coming up, and creators are finding out about this and migrating over to Web3, right? So these are applications that are built on top of Web3 infrastructure and that are Web3 native video applications. And a lot of the benefits here include creators can actually own the content that they create, right? Which means when they upload their video into like an OpenSea, for example, they actually own that content, which means they can take that content and repost it to Zora or Superior or any of the other NFT platforms, right? And they can take their audience with them as well. If we peel back the curtain a little bit and take a look at the actual infrastructure and how the Web2 video application is built, right? We see that on the bottom left, we have the video source, right? Video can either be uploaded as a file, or they can be live streamed as a broadcast stream. It gets ingested into a media server. And this media server is crucial for serving that video content, right? And because it speaks all these different video protocols, understands video codecs and things like that. the media server usually transcodes the video with a transcoding engine, and it can store the video into an object store or distribute that through a content delivery network into a video player that's in the browser. And of course, on the other side, right, applications usually have a database that stores kind of user information, and as well as server logic that, for example, brings up recommendation engines and things like that that are custom to the application itself. So if we go to the Web3 world, we see that a lot of these blocks are still in play, right? But they're swapped out to be replaced by decentralized solutions, right? And these decentralized solutions are public by nature. And so, for example, the video still gets uploaded and still gets streamed in, but instead of into a media server that's run by a proprietary, by a company, it's streamed into a decentralized streaming network, right? That then, stores the video into a decentralized storage system, like like a IPFS, Filecoin, or Arweave. It can get distributed by a decentralized CDN, and at the same time, the database is swapped out by with a blockchain, right? So the blockchain address is now the representation of the user identity, and of course, we also have the smart contract and the decentralized query layer to power these decentralized applications, right? So if we come back and revisit what this stack looks like, right, at the bottom we have the smart contract layer that gives us token standards, gives us ways to transfer value, gives us ways to create identity, right? It can plug into DeFi. It can give us these decentralized coordination mechanisms like DAO creation and things like that. And that's kind of the foundational layer of the source of these the source of decentralization, right? But on top of that, we have these Web3 infrastructure layer that allows applications to be built in a decentralized way, because at the end of the day, in order to build applications, we still need infrastructure to power these applications, right? So these are kind of decentralized storage solutions, decentralized data query solutions, or like decentralized video streaming solutions, all for powering these Web3 video applications, right? And we're starting to see these applications pop up in the kind of these different verticals like decentralized social, NFTs, metaverse, even like video-specific wallets or commerce use cases, right? So let's take a look at the primitives of Web3 video, right? Like what does Web3 video have that that's different from Web2 video, right? What are some of the new things that people can use, developers can use to build new types of applications? The first one is video-based NFTs, right? So NFTs are basically represent digital ownership, right, of some digital asset, and in this case, because video is a native digital asset, right? Video NFTs represent the digital ownership of a video, and this is quite significant because as soon as you have ownership, you have commerce opportunities. People can trade the ownership of these videos. People can attach royalties to these ownerships. So, for example, you can say, for the original creator of a video, the creator will get a percentage of all the trades that happen on this video in perpetuity, right? Another interesting aspect to this is because these NFTs are public data by nature, right? They're not stored in a centralized database. You can have multiple applications that are built on top of the same video assets. That starts to get really interesting, right? Because in the Web2 world, once a video is uploaded into YouTube, that video is viewed in YouTube, right? It's shared in YouTube, and it's living in the YouTube realm, right? And YouTube doesn't allow you to easily export that video out of YouTube. And in fact, it's against the user agreement. But in Web3, it's the opposite, right? When users are uploading videos into Web3 infrastructure, they own it, and they're just simply uploading it through an application interface. But at the end of the day, that video can be taken into other application interfaces. So multiple applications can be built on top of the same video assets, and that gives us a much more a pretty open space to explore, right? So for example, it encourages this mod culture where people can take an existing video, modify it, create a new video. This is actually quite a popular behavior on TikTok, right? People are kind of copying dance moves and things like that. But also, this serves as an important tool for community building, where videos can be kind of exclusive content for a community of users or token holders and things like that. Right? Moving on to the second point, which is video and smart contract integration. That's a new primitive for Web3 video, right? So this, for example, gives us the ability to create a completely decentralized video application. And some of these features can include, token-gated video libraries or token-gated live streams. But it also gives us the ability to decentralize the video production process, right? We're starting to see DAOs or Web3 communities come together and fund the creation of video. For example, we're starting to see some documentaries about the decentralized tech space, crowdfunded using kind of Web3 based primitives, and even creating liquidity using DeFi principles, all to encourage content creation. And finally, the metaverse is, I think, a really interesting building block for introducing video experience, because there's just a lot of need in terms of streaming into and out of the metaverse, right? We're seeing all kinds of interesting examples that we'll go into later. So yeah, with all these new primitives, what are the actual opportunities that we see in Web3 video? Well, one is, for the creator economy, right? NFT e-commerce is starting to become a pretty normal use case, right? We have these popular NFT platforms where creators are coming in, creating NFTs. We're increasingly starting to see video-based NFTs being created. So yeah, I think there's a lot of room to explore in terms of what a video native NFT platform will look like. So applications like Glass.xyz is actively exploring in this area. Another interesting sector is kind of these creator community tools that are popping up, Mirror being a really good one, kind of the Web3 version of Medium, right? But it gives people the ability to do crowdfunds or launch tokens on the writing that they do. And we're starting to see creator tools that are popping up for video specific use cases too. Web3 powered fandom, right? This is a pretty interesting vertical. NBA Top Shot is probably the most famous example here in a video based NFT use case, right? But we're starting to see all kinds of interesting celebrities coming into the space, trying to find new ways to connect with their fans through these Web3 native opportunities. Decentralized social application is another interesting area that we're starting to see some development. So Portal is kind of a Web3 version of Twitch. Beam, I would say it's a mix between like a Web3 Twitch and YouTube. Discover is kind of like a Web3 version of Reddit. So we're and there are like some interesting communities that are forming around these Web3 decentralized social projects. Some of these projects offer a token so that the users can actually become an owner of the platform instead of being a product of the platform. And some of them have even more interesting kind of incentive mechanisms to encourage content creation on the platform. We're already starting to see people streaming in and out of the metaverse, right? So we have kind of both, kind of real world people creating content to be viewed in the metaverse. So on the bottom left, right, we see this woman kind of creating a metaverse native kind of video experience, and we also see video being streamed out of the metaverse into the real world. Right, we're starting to see these kind of anime characters who are the celebrities. Right, so these are completely made up celebrities that are super popular. On the top left, we see like a real world concert of these animated characters. Going into the developer toolkit a little bit, I'm going to show you a few things that LivePeer has built over the years to help you build Web3 based video applications. This one is a video NFT API that we recently built. It's a really simple way for anyone to create video-based NFTs. So, a two-step process, right? The first is you export your API key from livepeer.com into your local environment, right? So here, I'm kind of copying the API key over to my local environment. And second is, I'll pick a video that I want to use to mint an NFT. Right here, I have my dog playing in the snow, having just a wonderful time. Now I want to mint that video as an NFT, right? So all I do is, I have this script. There's also a kind of NPM package for this. So when you execute this, it'll do a few things. One is it uploads this video into the LivePeer network. Second is that it processes this video to optimize it for kind of video online streaming to make sure it's actually optimized for streaming and it's viewable. And then it packages all that information into a nice metadata blob to get it ready for minting, right? So now you have this token URI that's already well formed, and you can use this to simply issue an NFT by calling a transaction. And in this case, I'm doing it on the I think on the Webrtmp testnet. And now I'm just waiting for the transaction to confirm, and once it's confirmed, we'll see there's a transaction ID, and we can even go into the testnet version of OpenSea to immediately see this minted NFT. Right, so we'll go there, and we'll see that. Great, here is my dog playing in the snow as an NFT. Another tool that we've been working on for a long time is this live streaming API tool that allows you to create kind of a Twitch-style video streaming application within 15 minutes. This is a pretty easy to use tool, and it's built on top of the LivePeer network, kind of like a hosted gateway service for the LivePeer network, and leverages the network to be able to provide streaming service at a super affordable rate. Another piece of technology we recently open sourced, it's called Mist Server. This is a really powerful video streaming media server that allows you to build kind of a video infrastructure, right? It has a deep integration with the LivePeer network, so you can deploy an instance of Mist server and be able to run a large amount of traffic through that Mist server, kind of utilizing the LivePeer network for scaling out that computation. Right. And finally, we have a kind of an in-browser broadcasting tool called Webrtmp. So this allows you to kind of create an application that allows anybody to broadcast a live stream from within a browser instead of needing people to download a broadcasting software like an OBS. Right? There's some good demo applications that you can take a look at the LivePeer GitHub repo. For this hackathon, LivePeer is putting up $5,000 of total prize. The first place prize is for the best video NFT platform using the LivePeer NFT API, right? So that's kind of the demo that I showed a little earlier. Definitely go check out the resources and the tutorials at the LivePeer Hacker Quick Start Guide. We walk through exactly how to use it, and you can use it to start creating your own NFT platform or even adding NFT functionalities into an application that you're creating. Another prize that we have is for $2,000 going to the best decentralized game streaming or creator platform, right? So this is a pretty open-ended prize. We'd love to see your creativity around how to use Web3 to create interesting incentivization schemes that allow people to want to create content or to create liquidity for their viewers, passing the value to their to the users of the streaming platform instead of kind of having the platform keeping all the profit. And of course, last but not least, LifePeer is hiring. We're hiring across engineering, product, marketing, and developer evangelism. So if you're interested, definitely go take a look at lifepeer.com/jobs, where we have posted all the jobs. So thank you very much, and we're looking forward to see you in the Discord hacker support channel. We have a lot of team members there. Love to help you on your hack, talk through your ideas. Yeah, thank you. Bye.
This talk is sponsored by Polygon. This talk is sponsored by This talk is sponsored by Polygon. Polygon is the leading platform for Ethereum scaling and infrastructure development. Its growing suite of products enables developers to build scalable, user-friendly dApps with low transaction fees without ever sacrificing on security. Learn more at polygon.technology.
All right, what's up, Web3Con, Developer DAO, anyone else who's watching this in the future on the internet, anywhere. Super excited to be here today to talk about how to build and scale your blockchain applications using Alchemy. So real quick introduction, I'm Albert. I go by That Guy in Tech on all social media, the metaverse, ENS domain, whatever. If you look it up, it's probably me. I worked at a couple of different SaaS companies as a software engineer before joining Alchemy and Web3 full time. So companies like Salesforce, Magoosh, and Samsara. As you can tell, I love building tools and helping make sure that developers and end users have a great time using whatever the service is. And so before I went full time into developer advocacy, I had worked on an NFT project with my girlfriend and a couple of friends. We built the Chibi Shinobis project. And for people who don't know, Chibi Shinobi stands for cute ninjas. It means cute ninjas in Japanese. And this was inspired by Naruto, one of the most famous, popular Japanese animes in the world. And so I had written the smart contract side. I had worked on NFT art generation with my girlfriend, who's the artist, and a couple of other artists that we brought on board. And we created this project, and I thought it was amazing just to see like this entire flow. And it seems cute. It seems like, oh, cool, like whatever. Collectible NFTs. We've been there, done that for a while now, but it really opened my eyes to this entire process. Anyways, in my free time, whenever I do have free time, which is rare now, I do like to do some raps as well. So if you're interested in this rap, I'm not going to show it here. Go to my Twitter profile, it's a pinned video, and you can watch it there. But this actually kind of kickstarted my whole career. It tells the story of how I got into crypto and how I ultimately ended up where I am today. Awesome. So now my role is a developer advocate at Alchemy, and my job is to empower developers to build on the blockchain. I love learning and then sharing my learnings and enabling others to build. So super excited to be here. Now, real quick, a quick overview of of Alchemy as a company. Our whole mission is to empower builders to bring the magic of blockchain to the entire world. And the way we think about doing that is we think about how do we make blockchain as a technology grow and mature. And we do this by going through this product lifecycle, where ultimately we want users to benefit from this technology, whether it's a new financial system, new digital assets and ownership and identity, all this stuff. We want people to benefit from that. But in order for that to happen, we have to have really good products. And in order for really good products to be made, we need developers who can piece together all of the bits and like the low level technologies and the new information that are coming into the space to build those products. But when that happens, we create this virtuous cycle where developers are making good products are incentivizing new users to join. And the more users there are, the more developers want to build and can afford to build and all this stuff. So the pain point though, is that it can be difficult to build products and new technologies because, think about running your own node, think about like developing things when there are no libraries or SDKs or APIs, and you have to kind of do everything bit by bit. It's like pretty hard. And so that's where Alchemy's focus is. We want to shorten that gap so that we can increase this velocity of the cycle and then bring blockchain to as many people as possible. So we've been doing pretty well so far. It's, whatever we've been doing has been working. We power a majority of the top applications in the space, whether it's Web3 companies or, Web 2.5 companies that are bridging the gap. We also power a majority of all NFT platforms. So, OpenSea, Maker's Place, Super Rare, Axie Infinity, blah, blah, blah. And the question is, how do we actually do this? We actually have a whole suite of tools. We're not just an inferior alternative. We have a whole bunch of things that are going on that I'm going to walk you through. So what tools does Alchemy provide? We have the first thing that you know and love is Supernode. It's basically the connection to the blockchain. So anytime you want to read or write data to the blockchain, you're probably going to be using our Supernode product. Basically what we've been able to do, and that's being depicted in this complex diagram here, all you really need to remember is that we've figured out how to run a bunch of nodes and create this engine that solves the problem of reliability, scalability, and data consistency. So that whenever you want to read and write information to the blockchain, to and from the blockchain, we'll get it to you ASAP. And a lot of people talk about decentralization and, oh, wow, you created this thing, but now everybody depends on it. You can use another service provider. You can run your own nodes, but we've just figured out a way to make sure that information can scale as you're building websites and applications and deploying your smart contracts, and is data consistent so that you don't have like all these uncled blocks and dropped, reorgs and stuff like that going on that affect your development workflow. And so this is the bread and butter. We'll see this later in code demo. The other things that we have though are nice dashboards. So we have our build product where you can search historical requests. You can see requests per second. You can see success rate. You can visualize your mempool, a bunch of these like dashboard features, which are super nice. And then if you're more on the business and analytics side, or like you're in that mood to optimize those things, we track these performance and user insights for you. So you can actually know where your requests are coming from, whether it's, the United States or some other country in the world. And then also within, the countries, which area is it coming from? So that way you can maybe optimize your product or optimize your latencies or whatever it is. And we'll give you usage analytics, application health alerts, and a lot more. And then Notify is another really important product. With Notify, something that's really cool is that we can actually push information from the blockchain to you, to your servers via webhooks. And this is actually something that's pretty hard to do with blockchain because as data is coming in, if you wanted to track, a certain transfer, a certain sale, a token swap, whatever it is, you normally would have to pull the blockchain and keep asking, hey, is that information up to date? Did anything happen yet? Did anything happen yet? And then like index those events and then maybe serve it on your website or your application. But we already do that. So we can, just let you know, hey, your user who's tried to swap a token, their transaction completed, so you should let them know. So, we track things like transaction status, address updates, and gas price changes, and I'll show you the interface for this later as well. So, and then we have enhanced APIs, and these are super crucial to most people, especially for, maybe like a hackathon or you're trying to like build stuff really fast. We have these higher level abstractions called enhanced APIs that can, let you query for things like transaction history, token information, connect to WebSockets, things like this. And our NFT API that we just launched falls under this kind of category of enhanced APIs where, you don't have to filter through all these events and figure out NFT stuff for yourself. We've actually done that for you, and you can just query, which address owns which NFTs and things like that. And then finally, this is not like a technical product, but this is equally as important, especially in the crypto space where you're trying to build community, you're trying to market. When you are ready to launch your project, Alchemy Amplify is there for you. You can offload your go-to-market strategy or a portion of it to us. You can add the certified infrastructure alliance badge to your website to give it more legitimacy. And then we can spotlight your project in our newsletter, on our social media, LinkedIn, Twitter, wherever it is that you want to spotlight it. We have a big audience there, so we can help you with that. Awesome. So that's enough overview of these products. Let's actually see these tools in action. I kind of want to show you, what a workflow is like from an indie developer perspective when I'm creating a new project, and then eventually how do I use enhanced APIs and Amplify and stuff like that to bolster it. So let's see these tools in action. What we're going to do, and this looks super shabby on the slide, but I've basically forked projects like Loot and Developer DAO. Shout out to Nader for who created Developer DAO and made content about this type of code. But we're gonna make a generative NFT collection, and I'll show you how Alchemy plugs into this developer workflow through the entire project. We're gonna develop a smart contract to deploy this NFT, and it's gonna be a collection of 8,888 of these randomly generated word lists that describe you as a Web3 hacker. And then we're also gonna build a really, really basic front-end website that helps you mint that NFT and visualize those NFT using Alchemy's enhanced APIs and NFT API. So, and just to show you, if you're not familiar, the Developer DAO tokens collection on OpenSea is right now it's about 8,000 items, just under. And this is what they look like, a list of words, and people have been trading them. And this gives you access to the Developer DAO Discord. And so, maybe we can do something like that, or we can partner with Developer DAO. And then we have Loot. This is the OG project by D. Hoff. He created Loot for Adventures. And the whole idea with this is like, hey, let's make a bottoms up NFT project, right? Where it's not art, it's not an art collection. It's actually something that the community can build on top of and make, apps and visualizations and battles and all this other stuff. So it's a fun idea. So that's what we're going to build today. Now let's exit out of this and I will actually show you. So the first thing is, if you want to follow along, there's actually code for the smart contract in this repo. So it's thatguyin.tech/hackers-nft, github.com/thatguyin.tech/hackers-nft. And the front end website is hackers-nft-dApp. Okay. So we have two separate repos here. Now, in this first repo for Hackers NFT, what I want to highlight here is, let's go in here. We have obviously the contract. This is the first thing that's really important. It's the contract that we're going to be working with it's called Hacker, and it's an implementation of the ER721 standard. So it's called Web3 Hackers. The token is called Hacker. There's going to be 8,888 of them. And then I've created these, word lists that describe like, what's your hacker type? And there's all these different types like full stack developer, backend architect, front end genius, block engineer, blah, blah, you get the idea. And then there's also these moods. So what mood are you in usually while you're hacking? And then here are some chains that you like to hack on. And then what's your Myers-Briggs? This was totally random, but I thought it was fun because I liked Myers-Briggs things. And then there's all these other word lists. So if you want to look at this, go to the repo. But this is the contract. So this is the contract file. And the important thing is, where does Alchemy come in? We have this hard hat configuration. Right now in this project, I'm using hard hat and ethers, but you could be using Python. You could be using some other SDK, some other development environment. And the key thing here is that Alchemy for Supernode, when you're communicating with the blockchain, all it is this URL endpoint. And right now, for good practice, I'm putting it in my end file. And normally you don't want to show this end file to people, but for the purpose of demo, I can show you this. It's like fake information. But I've set up, an Alchemy Rinkeby URL with an API key, and then an Alchemy Ropsten testnet URL with an API key, and then a mainnet one with an API key. And then I have my, private keys, but these are fake. And then in the hard hat config, you can see I'm actually loading the Rinkeby URL, the Rinkeby private key, the Ropsten URL, Ropsten private key, mainnet URL, mainnet private key. And so when I want to actually deploy to a testnet or deploy to a mainnet, it's as simple as running this script. So I actually already have some of these loaded here, but you can see here, this is like Rinkeby. So npx hard hat run, I have a deploy script, which I can show you. It's this script right here. Super simple. It comes out of the box with hard hat. Depending on what like developer environment you have, it'll probably be different, but we're just getting the contract factory, we're deploying it, we're waiting for this deploy transaction to finish, and then we log the address that comes out. So I've already run through these, but this is what the script looks like. And so when you call this command, for example, with the Rinkeby network flag, it will access the Alchemy Rinkeby URL. And then after you do this deployment, I can show you on our dashboard. I have a bunch of apps. These are all the apps that I've been developing with, but I have one for the Web3 Hackers smart contract, but on Ropsten. So if we click into this dashboard for this application, you can see I have a lot of requests here because I was doing a lot of test deployments and mints and all this other stuff. But the beauty of having this dashboard is that you can see all the requests that are coming through. You can see how many requests are actually succeeding or failing because we have these different tabs as well. So out of all the requests in the past 24 hours, there was 0.1% that were invalid. And you can see there was one, what it was actually get NFTs API call to Alchemy. But you can see at a glance, like the most recent requests, you can see the rate of requests or the number of requests over time. And then here's the monitor dashboard where you can see, since it's just me querying it and I'm in California, all of the requests are coming from California. So that's what's happening here. And then I can deploy it, I can interact with it on the testnet, and you also get this nice mempool overview. So right now this is all apps, but if I wanted to filter down to just my Web3 Hackers Ropsten testnet one, you can see these are all the transactions that were successfully mined and everything in one view in the memory mempool watcher. So let's say I'm ready to deploy to Mainnet. It's as simple as going over here. Let's clear this. Or I'll just look up the command because I've already done it once. I don't want to do it again. It's just switching a flag if I'm using something like hardhat. And then what's going on under the config is I'm just using a different Alchemy API URL endpoint, which I've stored here, ethmainnet.alchemy.apio. And you can see in our dashboard, this is where I actually pulled from. I should have showed you this earlier. And we go to apps and to my mainnet app that I've created just for this. You can click this view key button. And this is where you get your API key, your RPC URL endpoint, and then if you wanted to do WebSockets, we have that as well. So yeah, that's how you would connect and deploy. And you can see here also, we have our most recent requests. We deployed it, we got the transaction receipt, we have no invalid requests so far. Life is good. So that is deploying the smart contract. And then we have the front end website as well. So on the front end side of things, we have a separate repo. And if you want to follow in on the front end side of, fork this repo to make your own front end website, your own minter, your own display, this is the repo. So it's github.com/thatguyintech/hackers/NFT-dApp. Okay, I already showed you this. And so in this repo, how are we using Alchemy? So it's very similar, except we're not deploying a smart contract, but this time we're using providers. And actually, I should show you the website. So this is the website. If you go to hackerdao.com, it's live. You can actually visit this. You can connect your MetaMask. And so I'll just do a demo real quick. So let's connect my MetaMask. It'll pop up this window. And yep, this is the account that I want to connect with. And then it'll show you, boom, you have an ENS name, you have your address that's connected. This is the network that you're connected on via MetaMask. We don't have support for Wallet Connect or anything like that, but I can add that later. And then here's like a warning, you should be connected to Mainnet in order to mint and view your hackers. And then there's two tabs, and this is my really janky navigation here, but on the first tab, if you click on Mint, this is the Minter page. And you can see this is the contract on production that we've pointed to that we're currently about to interact with. So if you wanted to verify it for yourself, I should verify this contract. I'll do that later. That's the contract. And then if you wanted to mint, you can click that button. It would issue a request, and then MetaMask will ask you to sign. It's free to mint. You just have to pay gas fees, but I'm not going to do that right now. And then it also shows you how many tokens are remaining available for mint. Then over here on this other tab, we can view the hackers. So right now on this address, I have minted one hacker token, HackerDAO token. And so this is my word list. And so if I minted multiple, it would show multiple. But yeah, this is like a pretty bare bones, obviously, website for what a lot of people may be doing, right? And let me show you how Alchemy helps with all of that. So in our application, we have our app.js. This is kind of the entry point. This is the homepage. And over here, I am using the WAGME library, which is super nice. Shout out to the WAGME library. This is their documentation page. You should look this up. It's like a bunch of React hooks that makes development pretty easy. And so I have this WAGME provider that wraps it, and I'm connecting to the blockchain, not using the default provider, but using an Alchemy provider. And I'm instantiating that just like this. It's like literally 2 lines of code with my API key and with Mainnet. And that allows me when I am, as a user, trying to connect, trying to mint, whatever, I'm using the Alchemy connection to make sure that the process is as smooth as possible. There's no drop transactions. There are no hiccups. So that's the connection there. And then the enhanced API feature is the NFT API. So over here, we have under the source utils files library or repo, we have this file called Alchemy NFT API. And this is where I've implemented a utility function called get NFTs. And this actually hits the enhanced API endpoint get NFTs right here. So I pass in my API key, I get NFTs, and then this is the contract address in production that I want to filter on. And then over here, I return a bunch of data. So I want to return the name of the NFT token, the image URL, and then the token ID. And then over here in the nfts.jsx routes, you can open that up. I'm actually calling the get NFTs function. See that? And then I'm passing in the address that is connected to the website. This is another WagMe function. So after I've connected, this is the address that's passed into the call. And then once I get a response using this use effect hook, I actually load it on the page. And that's how we see this information right here, Be My Hackers. So that's pretty cool, right? Like all this stuff, Alchemy can help you build. And so a couple other things, sorry, brain fart. A couple other things I want to show you here. So before we wrap up, there are a bunch of other enhanced APIs. I just showed you a couple. And oh, we have Notify. Let's go through Notify real quick. So on Notify, this is basically the webhooks where we're pushing information to you. So we have address activity, drop transaction notifications, mine transaction notifications, and gas price for when you want to, get notified for when gas price drops below a certain point to like do something. And then what's cool is like, we can push information to you. So I'm tracking the Crypto Coven NFT project, and I'm using this for Crypto Coven SalesBot app, which is pretty nice. And then for enhanced APIs, I just showed you one endpoint on the NFT API, but we have all of these other endpoints for trace, debug, token metadata, transfers, token balance, whether you're building a wallet application, an exchange, whatever it is, we're going to build NFT APIs, or we're going to build APIs for you. And then finally, we have Alchemy Amplify. And I touched on this a little bit earlier, but this is, our way to help you market your project once you're ready to go. And so, there are a lot of projects that are already part of the Alchemy Amplify partnership. And one thing that you can do, let's zoom out there, is join the Certified Infrastructure Alliance. This is a badge you can add to your website to add legitimacy to your website, because basically this says you are using Alchemy infrastructure, and Alchemy infrastructure is the best in the industry. We have a supercharged newsletter that has tens of thousands of readers every single week, so we can feature your project when it comes out. And then, of course, we can hype you up on all of our social accounts that already has a huge following. And some examples of logos or companies that already use the Certified Infrastructure Alliance and have been benefited from Amplify. Diversify is a decentralized exchange. You can see, boom, they have their badge down here. We have the Full Send Meta card. This was an NFT project that had minted out, or like sold out in like a minute or two, $20 million plus, I think, on just the mint. And we helped make sure that their mint process was super smooth, no hiccups. Everybody who submitted a transaction was able to get it through, and they weren't blocked on the node provider aspect. So they have a badge. Rarible is another one too. So awesome. And then the other thing about scaling is once you've built out your entire, you've gone through this workflow of building your project, and you are, getting some users, you want to make sure that all the transactions going on your website are smooth. We have actually this growth tier. So we go into settings here, billing. You can turn yourself onto growth tier. And what this does is it gives you more requests. It gives you higher rate limits. It gives you more applications. And then also if you submit, payment information, then you can turn on auto scale. So with auto scale, if you were to go above this request limit and you needed more support, basically we can do that automatically for you. So interruption, there would be no service interruptions. And then if you need anything beyond this, you need custom rate limits, you need unlimited applications, or you want like custom 24/7 support and a bunch of other things, you can contact us for an enterprise plan. So that's, we take our customer support really seriously, because that is one of the ways that we can make sure that this entire industry evolves in a positive way. So yeah, hopefully that was super useful for everybody out here. If you want to get a free NFT from this website, so if you don't want to mint one for yourself, but you want to get a free HackerDAO NFT, what I want you to do is screenshot your favorite feature or moment from this presentation, and then tweet at me. So I'm at that guy in tech, and also include Alchemy platform in your tweet. And then tell me in that tweet what was the most useful. And this is a great way for me to get feedback too on what's standing out to people. And if you have any questions about Alchemy or any things that you want me to make a further tutorial on, I'm happy to do that. Just include that in your tweet. The first 5 people to include that, to issue that tweet, to publish a tweet, I will airdrop an NFT too. So yeah, hopefully that was useful. Happy hacking. Hope you all are building great things out there. And we're excited to keep supporting all the developers in the space. My name is Albert. And yeah, that's it. I'll see you later. Bye.
This talk is sponsored by The Graph. The Graph is a decentralized protocol for querying blockchain networks like Ethereum and IPFS. The Graph serves over 2 billion queries per day with thousands of subgraphs deployed for gaming, NFT, and DeFi Web3 applications. Learn more at thegraph.com.
Hello everyone, my name is Pirella, and I want to welcome everyone that's watching this conference right now and who will later watch the conference too. It is my great pleasure to be here at the Web3 conference, and I have to say it's amazing to see how as a community we're coming together in this kind of conference just to talk about our favorite technologies, to talk about our favorite networks, to talk about how to solve issues with applications in Web3, how to solve issues in a decentralized way. I cannot stress enough how amazing it is to see all this community growing in Web3 and how passionate people are working towards Web3 applications. It's really visible. It happens on Twitter, it happens in GitHub. You can see a lot of development being worked on regarding Web3, and it is really mind-blowing. And I think many of us here are here for that reason, because we're passionate about Web3 applications and solving issues in a decentralized and fair way. With that said, I want to thank the Web3 conference for having me today, and I also want to thank all the different speakers that we're going to have throughout the day and throughout the next few sessions, because we're all here for the same purpose and we're all here to talk about amazing things. So thanks everyone for watching, and thanks the staff that has made this possible, and I want to thank all the speakers as well. I'm going to be focusing on our Webrtmp 3M, and I'll talk later about it with some examples. I'll be sharing my screen and you all can see what I'm referring to. But first, a little bit of background. What is Arweave? Arweave is known as the permaweb, the permanent web. Arweave is a blockchain meant to store data, any kind of data. Just like Bitcoin is meant to store Bitcoin transactions, and Ethereum is meant to store a state of contracts and contract source code and Ethereum bytecode and execute those contracts, Arweave was meant to store data. And it was meant to store data in a way that's scalable and in a way that's cheap. Right now, as I'm speaking, it costs you $7 or around 0.25 Arweave tokens to store 1 gigabyte of data inside the Arweave ecosystem. And that's going to be distributed, that's going to be consensually open, and it's going to be in the permaweb. It's going to stay there forever. So if you want to become a node and connect to the Arweave network, you're going to have access to all this data people are constantly sharing. And it's really mind-blowing everything that you can do with the PermaWeb. You can store all kind of files. You can store binary files, you can store images, video, PDFs, JSON files, text files, anything at all. You can store anything that can be part of your computer, you can store it in Arweave. And right now, while the community is growing, it's really impressive to see all the usages of this. For example, right now the Arweave team started the Russia-Ukraine initiative, where we're storing all the data related to Ukraine and Russia, the current situation that's going on. And the reason why we want to do this is because we want to protect the data in the PermaWeb. As Sam Williams mentioned, founder of Arweave, we don't care whether that information is true or not. We just care about storing the data. And with the PermaWeb, we're gonna let historians figure it out, because they're gonna have access to this data. They're gonna have access to this data that cannot be modified. They're gonna have access to all this data that's immutable. So historians in the future can modify this. The PermaWeb is the evolution of the way we store data, just like we did with books, and just like the Egyptians did with paintings on rocks. Right now, humankind have the ability to store data and pass it to other generations and pass it over time without the risk of it being lost, without the risk of it being manipulated, which is a risk that existed until a few years back. You could modify books, you could modify anything, but you cannot modify the PermaWeb, or you cannot modify any blockchain, for instance. So the PermaWeb, dedicated to scale and to store data, makes possible a lot of things. It makes possible the transmission of the information through generations in an immutable way. But it also makes possible a new concept. It makes possible lazy smart contracts. And what is a lazy smart contract? A few things here. Smart contracts are usually, the way we think of smart contracts is not usually in a lazy way. So smart contracts in platforms like Ethereum or like Near or any other platform, any other blockchain that accepts smart contracts as a first-class citizen, it's all based on a global execution, a global machine, a global state. So whenever you send an interaction to the Ethereum network is gonna catch that interaction and it's gonna execute it, and all the nodes are gonna agree upon this result of that execution. Along with that execution, you have things like gas, you have things, different fees attached to the interaction that you're doing to the smart contract. And all these computers around the world execute the same code, execute the same interaction, which is the input of the smart contract, and agree upon the final state. And this happens every time the contract receives an interaction and there's consensual agreement on it. But this is all done not lazily, because you have all these computers, as I mentioned, working on that contract, actually executing that contract as soon as the contract receives a new interaction. As I mentioned before, with Arweave, you're able to store any kind of data, any file, anything at all, which opens the door to lazy evaluated smart contracts. And what is a lazy evaluated smart contract? Basically, the principle is, if you can save the source code of the smart contract in the PermaWeb, and you can save the interactions, the transactions that the smart contract is going to receive in the PermaWeb, you're going to be able to execute the contract and always get the same result. And why in the PermaWeb? Because the PermaWeb ensures the immutability of that source code. The PermaWeb ensures the immutability of those transactions that are being sent, and anyone can send interactions to the contract. With a few configurations, your contract gets readable. But you need some sort of execution machine. And that's why the Arweave team decided to create what's known as SmartWeave. SmartWeave is a standard and it's an execution machine currently written in Node.js, which pulls all these interactions and which pulls the source code and executes the contract. With this concept, you can easily write contracts in any language because, as I mentioned, you can upload any kind of files. Right now, it is possible with Rweave in Smart Rweave to write contracts in JavaScript, which is something not so common. And it is possible to write it in a deterministic way, which means the same input is always going to lead to the same output of the contract, also known as the state. There have been a few inventions out there that make this possible, such as 3M, but I'll talk about it a little bit later. Right now, I want to focus on this concept of lazy validated contracts, with the principle that if your source code is stored in the blockchain and all your interactions are stored in the blockchain as well, then any person can run this smart contract in a secure way. Why? Because of determinism. Because the network ensures there's consensus on that source code and on those interactions, which means whenever an end user pulls all that through a software like SmartWeave or 3M, they're all gonna get the same output. They're all gonna get the same state. This is just because determinism and blockchain. Blockchain makes it immutable. Blockchain makes the source code of the contract immutable. Blockchain makes interactions of the contract immutable. And the executor, such as SmartWeave or 3M, may just interpret all the source code. And that leads to lazy validated contracts. Which means every time you want to run the contract, every time you want to reassure the contract is valid, you just need to load the executor, put your contract ID, and the rest will be done by the software that's interpreting those interactions. And I'll show a few examples about it. 3M, on the other side, is a contract execution machine. And it's called 3M because it was meant to be known as the Web3 execution machine. 3M allows you to write a smart contract in different languages, such as Rust, JavaScript, C, C, C++, and we're looking forward to integrating more of them. As part of the core team of 3M, we've seen a lot of growth in this concept of lazy validated contracts, and we want to keep integrating new languages so we can onboard new communities. Oh, I almost forgot. With 3M, you can evaluate Solidity contracts. So 3M is actually capable of running contracts written in those 4 languages I just mentioned, plus Solidity, or anything that's compiled to Ethereum bytecode. 3M is capable of doing that. And the reason why we decided to structure it this way is because we wanted to do one thing. We wanted to onboard members of different communities, such as the Ethereum community or the Solana community with the Rust contracts that 3M is capable of running. We wanted to integrate all members from different backgrounds inside the Rweave ecosystem. And we're successfully doing so as 3M grows in usage. Many applications out there are already using lazy validated contracts. To name a few, Vertu, which is a decentralized exchange that uses lazy validated contracts. And with the principles I mentioned, Vertu is actually able to securely and in a decentralized way transfer tokens from one account to another account and so on. All done in a lazy way. No need for a global computer or thousands of computers evaluating the same contract, as Rweave ensures that the source code and interactions are going to be there. So you only need to worry about running it. With it said, we're going to go into some examples on how to achieve these behaviors. Now that we're back here with the examples, I want to go with this quick presentation of
who I am and what I'm gonna be talking about in the examples. And since we have a very limited time, I will try to not extend so much, and I will just try to cover what's important about Arweave and lazy volatility contracts and everything that I talked before. So I'm Andres Pirella, as you know. This is an introduction to Arweave 3M and Web3, who I am. I'm a software engineer. I love outdoor activities, skiing, running. I love animals, and I live in the state of Florida, sunny Florida, in the United States. I'm very passionate about software, and I've been an architect and consultant for Web3, which I'm gonna touch ground in the future as we go down the road. And in the open source community, I'm part of the core developers of 3M, which we'll see in more details soon. So what is Arweave? Arweave it's a decentralized blockchain-based storage, which is also known as a permaweb. So if you read about Arweave, you might find the word permaweb very common inside the Arweave context. And the reason why it's called the permaweb, it's because it allows any type of information, any type of data, any type of files to be served, and the nodes have the ability to serve this data as regular files in URLs. So you don't need to do something technical. You don't necessarily need to do something technical, such as downloading a node to access the information, but you can access with an URL that's going to serve the data in the way it's supposed to be served. So one quick example about Arweave being a decentralized storage is, as I said, you can store any type of data, and nodes can actually serve the data. So for example, here we have this transaction that was sent, and it has a content type tag. It's a tag. So transactions inside Arweave have the ability to contain tags, which is metadata. You can put anything in a tag, or you can have as many tags as you want. And one regular tag that we know is content type. So right now, this transaction, this idea of the transaction, and this some sort of block explorer, this transaction is a content type application PDF, which tells us this is a PDF that's being stored in Arweave in the permaweb. So if I want to proceed and open it, I would do the following. And now this being redirected, this URL that I put here is being redirected to a node, and the node is actually serving this document. So it's not like it's being saved in Amazon storage or something like that. It's actually being saved somewhere in the world, in a computer, in a decentralized computer, in a node that's working for this decentralized network known as Arweave. And it gives you the ability to serve these files, and you can do this with pictures, with audio, and any type of files, or data. You can serve JSONs and so on. So if we go to this wallet has several transactions. I believe this is a JSON one. Let's try to find a JSON transaction. Oh gosh, they're all PDF. Okay. Okay, so here we have a JSON transaction. So the content type is application JSON. So if we repeat the same process now with this transaction ID, which I copied from here, we should be expecting a node to serve this JSON. And let's give it some seconds while it loads. And here we have we're getting JSON served from Arweave. So we're getting a JSON served in our browser from a decentralized computer, a decentralized blockchain network, Arweave. Now, moving on to a little bit of how can I upload a file, how can I upload content to Arweave. Well, there's different ways, and I won't extend so much in it. But there's applications out there. There's wallets that you can install in your browser as an extension, and you can actually upload a file. There's also AirDrive.io, which is some sort of Google Drive, but backed by Arweave. So everything that you upload here it goes to Arweave, and Arweave has a very competitive price. So with $9, which is the equivalent in AR, which is the native token of Arweave, with this amount of AR, which is $9, you can upload 1 gigabyte, and it has a very competitive price. It's not so expensive, and you only pay once. So after you upload a file, you only pay once for that file, and it's going to be stored forever in the permaweb. But I have an example here, a very straightforward example. I'm not uploading a file per se. I'm uploading a hello world, hello Web3Con. So here I'm importing this a Node.js file. Here I'm importing the Arweave package, and then I'm uploading it here, and then I'm reading from my wallet, I'm creating the transaction, I'm signing it, and then sending it to the network. So if I do this, I'm expecting this ID, and now we're gonna look for this ID inside the block explorer. We have from here, if I copy this ID and I go to arweave.net, which is the central, well, the gateway that interacts with nodes, and it's capable of serving this data to you. If I go here, which is the transaction we just posted with this content, we see we have a file downloaded, and if I open it, hello Web3Con. So that's with JavaScript. It's a very straightforward library, and you can upload any type of data, strings, JSON objects, buffers for binary files, images, PDF, whatever you want. And by adding tags, this way you can add, for example, content type, and then you would do application PDF if you're uploading a PDF. So the network is going to recognize that piece of data as a PDF file. We know what's Arweave, decentralized storage. What are lazy Evolated contracts? Lazy Evolated contracts are basically you upload the source code to the permaweb, to Arweave, and interactions, and then with an executor, which can be any software that's able to interpret those interactions, those transactions, are going to be able to generate a result. So for example, here we have a contract, and this in some sort of view explorer. Here we have the code, which is stored in Arweave. It's a JavaScript code. It's a smart contract written in JavaScript. Then here we have the transactions. The transactions are just JSON, as you can see here, the regular JSONs that you pass. And then you can read the state with tools like SmartWeave or 3M. So for example, it's loading all in the interactions, so it's pulling from the permaweb, it's pulling from Arweave, and it calculates the state. So it runs this code based on the transactions or the interactions that it's getting, and it generates a final state, which you can also see here. So that's a lazy Evolated contract, because Arweave is not computing, it's not doing any calculation to this contract, but you do it off-chain as a lazy evaluation. You only need to have the executor, which can be 3M or SmartWeave as the native project built around Arweave, and you can plug in the ID and use it. As mentioned, some of the Arweave smart contract executors, since this is off-chain, lazy Evolated, are SmartWeave and 3M. What is 3M? 3M is a fully deterministic, so unlike SmartWeave, which runs inside Node.js and a Node.js environment, it has a lot of security flags for the same reason, and you can use non-deterministic behavior. So 3M fixes all this by being fully deterministic. It's also secure, it's a sandbox, it has no access to syscall, so it's not like you can download a file and plug it inside the person that's running the contract. And it's multi-language, so it supports EVM languages such as Viper, Solidity, and it also supports Rust, SIG, AssemblyScript, C, C++, and JavaScript. It's blazingly fast. It's about 3 times faster than SmartWeave, and here we have a demonstration of what 3M looks like. So here I'm running this contract. I'm running this contract ID, which is the same one we run with SmartWeave, and now I'm gonna run it, and yep, here we have the state. So it's blazingly fast. It's way faster than SmartWave, as you can see, and it has all these features such as fully determinism and secure and multi-language. And this one, I'd say this is one of the biggest features of 3EM. Finally, I want to touch ground with what Vertu is. Vertu is a decentralized exchange that runs inside Arweave. So how does this work? Because Arweave doesn't support smart contracts per se, but it supports lazy contracts with off-chain executors, as shown before. So Vertu actually makes use of lazy contracts, and it powers a whole exchange where you can trade tokens, NFTs, and all those kind of things. So what I want to point out with this is that with lazy contracts you can have the same behavior, and you can have to some extent the same benefits of decentralized computers such as Ethereum, such as Solana, that are always running smart contracts. With lazy contracts you have a lot more flexibility, but you can accomplish the same, and this is very important to remark. On a last note, if you're interested to interact with Arweave, I highly suggest to check this package, arweave.js. It has all the information, and it's compatible with the browser and in Node.js, and it has all the information about how you can interact with Arweave, send interactions, send transactions, sign transactions. It's very detailed and very useful. So this has been a little maybe rush introduction to Arweave 3EM and Vertu. Don't forget to follow me on my Twitter, which I'm always posting things about this ecosystem. And if you have any questions, please do reach out. I hope you enjoyed this presentation, and I'll see you next time. This was Arweave 3EM and Vertu, and most importantly, lazy contracts, a new concept to the Web3 ecosystem. Thank you so much.
Hey people, my name is Krishank. I do all Hey people, my name's Krishang. I do all things smart contracts at ThirdWeb. Pretty excited to be giving a talk for Web3Con, and I have a talk coming up on a pretty grand subject, the subject being a developer's path to bringing Web3 to the billions. I have a nice tweet to kick this talk off, and it's a tweet from my friend Wilson. And he says, if I had a nickel for every time I saw someone say they're bringing crypto to the next billion people, I wouldn't even need to be in crypto, which is pretty true. A lot of people throw around the phrasing that their product or protocol is going to bring the next billion people into crypto. And when you hear it being stated, or rather, if you see it being stated in the title of a talk, it's pretty justified if you want to scoff at it. My own opinion is that it takes a couple thousand people like me and you to ponder on this grand idea for one of us to actually hit it out of the park and actually bring a billion people to Web3. So that said, a developer's path to bringing Web3 to the billions. Taken as a statement alone, it is a pretty grand statement. It is a pretty broad statement. Nothing that a simple talk can cover entirely. So what I treat it as in my head is a slogan. A slogan is something that people can rally around, and bringing Web3 to a billion people is something certainly we can rally around. Everyone's here at the Web3Con mainly because they think Web3 is actually good for the people. Everyone wants to bring Web3 to a billion people. And so throughout this talk, this statement is going to get the treatment of a slogan. It's a good rallying cry, but we kind of want to dig deeper, a layer deeper beneath the slogan. And so in my head, when we dig deeper, this being a developer-focused talk, comes the theme. And the theme I'm going to focus on is composability at the application layer. Again, treat it as a standalone statement. This is pretty broad. We can speak about the statement at a high level language, but as we go further along in the talk, we'll tie back this theme in. A theme is just something in the spirit of which we work. And the theme of this talk, something that we'll build up to, something in the spirit of which I will advocate that we work, is composability at the application layer. And again, digging deeper, going one layer below the theme, I would say, comes the strategy. Strategy that I'm going to espouse in this talk is build better abstractions that shorten time to productivity in Web3. This is a bit more specific than the theme, still pretty broad. We as developers work with abstractions all the time. What I mean by strategy here is the high-level direction in which we're going to work in the spirit of the theme. The strategy I have is more of a guiding strategy. We keep encountering and applying terminology like high-level or low-level. JavaScript libraries that we use to interact with smart contracts are an abstraction. Smart contracts themselves are an abstraction that we surmise, even more lower level details. A no-code smart contract builder is another abstraction that is useful for folks with no coding abilities. A key thing to remember is that you can have a tangible impact on software and its outcomes by just building at any level of abstraction. And so the strategy is, again, one of the things that we're going to tie back to in this talk. And I still want to keep digging deeper and go a layer beneath strategy. And in my head, when we do that, we hit something called tactics. And the tactics that I'm going to focus on in this talk, stated here as coordination, standards, and SDKs. Again, we know the direction in which we want to work in the spirit of the theme we've settled on. The tactics is a concrete order of operations, by which I mean tangible actions that you and I can take in the spirit of the strategy that we've settled upon. So how are we going to build better abstractions in Web3 that shorten this quote-unquote time to productivity? And I will argue that it is with better coordination, without any qualifiers, just standards and SDKs. SDKs being the most specific term being thrown out there. And if I would just throw out some tactics at you people, it'd be somewhat useless. It'd be just like me standing on my soapbox giving you instructions. That's kind of not what I want to do here. And so to tie these tactics to something, I'm going to provide an anchor. I'm going to provide an example. Very conveniently, I work at ThirdWeb. I want to explain the ThirdWeb architecture as an example of this chain of things that I've described here. This chain of things being the slogan at the highest level, the theme coming after that, the strategy, and then the tactics, and now getting into the ThirdWeb architecture as an example. What I will try to do in this talk is go bottom up. I will start by explaining the ThirdWeb architecture, and I will showcase how the tactics I want to advocate for will be helpful ultimately in achieving the slogan, how applying the tactics I'm going to talk about does let us successfully implement this strategy of building better abstractions that shorten time to productivity in Web3. And following that, I will show how implementing the strategy I'm describing lets us indeed work in the spirit of the theme we've settled upon, composability at the application layer. And ultimately, I will argue composability at the application layer is how we're going to get Web3 to the billions. So getting to ThirdWeb, before explaining the ThirdWeb architecture, our landing page says ThirdWeb makes it easy for you to build Web3 apps. That's a pretty high level explanation. This is a developer focused conference, so I want to give a bit more of a technical explanation here. What ThirdWeb does is give you an entry point into Web3 development at every level of abstraction. By that, what I mean is we provide a dashboard to create and interact with smart contracts to people with no code abilities. So that puts you at the highest level of abstraction. We provide SDKs in languages like TypeScript, Python, Go. These are languages that you do not use to write smart contracts, not counting Rust and all the lovely Solana folks out there. But we provide SDKs in already popular developer languages, which you can use to create and interact with smart contracts. We provide a UI kit. If you're a smart contract developer, all of our contracts are available in a smart contract library. So just like you npm install OpenZeppelin contracts, you can npm install ThirdWeb contracts. So that's what I mean by us providing you an entry point at every level of abstraction, an entry point to Web3 development. And if you draw that out on a diagram, this is somewhat how it looks. Here you see pretty much every layer of a working dApp, a working decentralized application. You have your front end, you have whatever tools you're using to get your front end to interact with a smart contract. You have a storage layer with IPFS there on the side. And then you have the actual smart contracts itself that are the single source of truth for your dApp. And what ThirdWeb does is here presented in the form of the SDKs we provide. But what ThirdWeb does is give you a tool at every level of this architecture for you to leverage to build out your dApp. And the thing that lets us provide you with these SDKs at every level of the architecture And how we get these pieces to coordinate together is that all of these pieces have some common information of how the smart contracts that are at the base of everything are going to behave. So let's say you have an SDK function on an NFT contract called balance off that gives you the total number of NFTs an address owns in an NFT collection. In that case, across the stack, be it the front end, the SDK, the application layer, or even the smart contracts, all of these three share some kind of common understanding that what's being queried here is the information of how many NFTs does this address own in the given NFT collection. So this is not really the true magic in my eyes of something like the ThirdWeb SDK. If you write your own contract and then you write your own SDK, and somehow all parts of your stack have a shared understanding of how your smart contract is operating, well, of course they do. And that's because you wrote the smart contract and you wrote the SDK that talks with the smart contract that you wrote. So there's no magic happening when ThirdWeb SDK is talking to ThirdWeb smart contracts. That should be pretty elementary. The true magic in my eyes is when, and this is possible with the ThirdWeb SDK today to a limited extent, the true magic in my eyes is when you can use the ThirdWeb SDK to interact with an arbitrary smart contract that the ThirdWeb SDK wasn't already anticipating, or a smart contract, say, that was not built using any piece of ThirdWeb. And the ThirdWeb SDK is still able to interface with that smart contract. And just to make a differentiation here between something like the ThirdWeb SDK and something like Ethers.js. Ethers.js is a direct wallet implementation. The ThirdWeb SDK is something that gives you a high-level API to interact with a smart contract. So again, to reiterate, it is easy for the ThirdWeb SDK or not really magical for the ThirdWeb SDK to have a high-level API that lets you interact with a ThirdWeb smart contract. It's magical if the ThirdWeb SDK has a high-level API that lets you interact with an arbitrary smart contract. Now, before laying that capability out of the ThirdWeb SDK, I mentioned it can do this to a limited extent. And that's because the SDK is limited in this domain to the kinds of interfaces that an arbitrary smart contract implements. So we all know of popular interfaces like the ERC20 interface, the ERC721 interface, the ERC1155 interface. An arbitrary smart contract implementing any of those interfaces can somewhat be anticipated by the ThirdWeb SDK. And the ThirdWeb SDK can successfully provide a high-level API to interact with a contract that implements one of those high-level interfaces. Now, something I will put out there is that high-level APIs to interact with smart contracts or any low-level stuff is actually desirable. And that's because it lets you get productive with the outcomes of those low-level things much faster. So that is one critical thing to accept if we're going to follow along this talk. It's that at some point people stopped writing C and developed a higher level API to do or accomplish the same lower level outcomes. So high level APIs are good. They're not always 100% better than writing lower level things, and it's clear why. That's because sometimes you do want to write code closer to the metal. Once we accept that high-level APIs are actually desirable, we can come to appreciate a fundamental hurdle with SDKs like the ThirdWeb SDK, which give you a high-level API to interact with arbitrary smart contracts. And it's that things like the ThirdWeb SDK depend on smart contracts implementing interfaces that the entire community at large has largely agreed upon to implement. And that's because what lets the ThirdWeb SDK give you a high-level API to use for any arbitrary smart contract, currently limited to popular interfaces like ERC721, ERC20, or ERC1155, is the fact that the developer community has largely agreed upon implementing these standards and considering, for example, an ERC721 smart contract as an NFT smart contract, or a contract that implements ERC20 as a fungible token. And so this brings me to tactics. Clearly, if we understand that high-level APIs are desirable, and we see that a hurdle for these SDKs or API generators to accommodate arbitrary smart contracts is the developers community's settlement on certain standards and interfaces, we can start talking about the tactics for getting over that hurdle. And the clear tactics in my eyes that stand out are just better coordination. And better coordination here really boils down to three things. I believe when it comes to our Web3 development community, it's advocating for the adoption of standards, improving upon existing standards, and coming up with new standards. And these, I would like you to hear these three points as something actionable and something that you can, in fact, start doing right away and have an outsized impact on the Web3 development community. To actually drill that in, I want to give an example for each three where a successful person or a team in the space has actually taken one of these actions. And so for advocating for the adoption of standards, here's Joey Santoro. He's the co-founder of the successful FAY protocol. And here he's advocating for the adoption of EIP 4626. It is in Joey's Twitter name. He's tweeting about it all the time. He is pushing the EIP in more traditional media like news articles of CoinDesk. So ultimately, this act of advocating for standards boils down to opening up the EIP website. And pardon my ignorance, folks outside of the Ethereum ecosystem. My vocabulary is going to be a bit Ethereum specific. But yeah, read up on the various improvement proposals of your ecosystem, get a sense of where the space is heading. Eventually, you will find improvement proposals that you find meaningful and you find useful. You find a standard that clicks with you, pick that standard up, read it, and advocate for the adoption of it. Find out who can adopt it and whose adoption of that standard can actually have an outsized impact on your entire ecosystem. A second thing is improving on existing standards. This one made a bit of a buzz. The team behind the successful Azuki project came out with a new standard that they themselves implemented for their NFT project, which was the ERC721A standard. It essentially reduced the cost of minting several NFTs in a single transaction, batch minting NFTs. And they did a great job at it. They did their research and they actually wrote a very nice article on it detailing the advantages of ERC 721A over the ERC 721 interface, and they wrote about the trade-offs too. So here's another option for you. Don't take standards like ERC 20, 721, 1155 as monoliths, just things that are going to remain the same forever. Go ahead and actually improve on their standards and write about it. Writing is essential here. If you can write about it and get people behind your improvements, maybe your improvement, your iteration over a canonical standard becomes the canonical standard over time. And the final point being, come up with new standards. For Ethereum, the EIP website has an entire page dedicated to detailing the process for publishing new EIPs. Come up with a new standard, publish an EIP, rally behind it, and maybe someone else comes in and improves upon your standard in the future. That's how the cycle begins. And so that covered all of the tactics that I had in mind. Again, I would like you to take away the fact that those tactics are actionable things. You can start advocating for the adoption of standards, you can improve on standards, and you can come up with new standards as well. What that ultimately allows for developers is to build better abstractions. Now that smart contracts will get started to be written in adherence to certain standards, tools like the SDKs can anticipate the behavior of these smart contracts. That's one way to think about building better abstractions or the outcome of better coordination. And what better abstractions do is they shorten our time to productivity in Web3 development. And I've had this time to productivity in big fat quotes throughout my talk. And there's a reason for that. I want to differentiate between two kinds of time to productivity. So there's this one kind of time to productivity that a good terminal will try to minimize. And that is simply you as a developer having an intent to write a program, and then the time taken for you to actually get started writing that program or finish writing that program. That's the kind of time to productivity that a tool like a good terminal tries to minimize. Now, this is all well and good, but the time to productivity that I would like to reference is something different. In the case of Web3, this is the time to productivity that I would like to reference. It is the time between your intent of leveraging a crypto primitive or a product and actually performing a full loop or MVP of that intent. An example of that is you encountering the idea of social tokens on Twitter and being like, hey, I want to create my own social token. How much time does it take you to actually spin up your own social token and execute a short experiment? That's the kind of time to productivity that I'm talking about. That's the kind of time to productivity that Third Web SDK tries to minimize. That's the time to productivity that better abstractions in the Web3 ecosystem will help minimize. And once it is pretty trivial to start leveraging different parts of Web3, these different Legos that we can now think of them as, we get something that I will phrase as composability at the application layer. By composability at the application layer, what I essentially mean is something that lets us build, for example, DeFi that my mom can use. I've been involved in the Ethereum ecosystem for about 2 years now, so not that much anyway. But it took me a damn while to learn how to use a product like Yearn.finance. It takes quite a bit of time to understand the underlying components of what this website then presents beautifully. And still, despite the great work of the people at Yearn building a clean user interface on the Yearn.finance website, it is simply not something my mom can use. And Web3 is something that my mom should be able to use because the ethos of Web3 is not limited to people who can grok the workings of Yearn under the hood. So on the right, I have Yearn.finance, sort of the current state of what I'd consider a more involved DeFi product. And I've chosen Yearn as an example. I realize I've been calling it Yearn. Maybe it's called Yearn. My apologies if it is called Yearn. Just realized that. But on the left, I have something called Joinburst, built by my friend Samir. Now, Joinburst is like Yearn, an aggregator of strategies, except how it operates and the amount of options that it exposes and the kind of user experience that it offers is at a different level of abstraction than Yearn. And any user of the do can immediately pick up on that. And so where we want to go is in terms of direction from the left to the right. If we do want to bring DeFi and Web3 to 1 billion people, if my mom can use your app, and it's in that direction of bringing 1 billion people into Web3. And what lets us do this, what lets us build Web3 apps that my mom can use, in fact, is composability at the application layer. If it is easier for me to plug and play into Web3 Legos at the application layer without having to write custom smart contracts from the get-go, it results in more apps in the direction of easier UX that my mom can use being built. And ultimately, this was the ladder that we climbed in this talk. We started at the third web architecture. We ended up speaking of tactics, i.e., better coordination, advocating for the adoption of standards, improving our existing standards, coming up with new standards, all with the goal in mind that tools like an SDK, for example, the third web SDK, can start anticipating the behavior of what is at the base foundational layer, which is smart contracts. Implementing those tactics ultimately lets us build better abstractions that shorten time to productivity. That better abstraction being something like the SDK that can now anticipate smart contract behavior. That results in composability at the application layer, which means if I wish to leverage several Web3 Legos, I can do so quickly. I can set up short experiments and test my loops out. And eventually, that means more apps that my mom can use, more Web3 apps that my mom can use. And that, in my eyes, is a developer's path to bringing Web3 to the billions. To tie it all in, just like in my eyes, the job of Third Web is to give you an entry point in Web3 development at every level of abstraction. The developer's path to bringing Web3 to the billions is somewhat similar. Start operating at any level of abstraction that you feel you fit at. And that may be at the level of tactics, where you're advocating or creating standards. That may be at the level of strategy, where you are building tools like an SDK that now anticipates smart contract behavior, leveraging all the good coordination that the others are performing. That may be at the lowest level of writing smart contracts and famous foundational smart contracts that adhere to certain interfaces that the community settles on. That may be at the highest level of things, bringing Web3 to the billions, coming to conferences like these, listening to the ideas, sharing your own ideas. And that's pretty much all I had to say. See you later.
This talk is sponsored by Decentology. This talk is sponsored This talk is sponsored by Decentology. Decentology is the innovative company behind the Hyperverse, the open, composable smart contracts marketplace that makes it easy for developers to build Web3 apps without writing a single line of smart contract code. Learn more at decentology.com.
Hey there, welcome to Stacks 101, Building dApps on Bitcoin. In this talk, I'm going to go over what Stacks actually is, give you a quick rundown of how it works, why you might want to build on it as a Web3 developer, and then we'll go look at a little bit of sample code. We'll look at Clarity, the native smart contract language that Stacks runs on. And then finally, since we're a little bit limited on time and I won't be able to do an actual full-on code demo, I have a link to a resource page that I put together in case you are interested in looking a little bit more into Stacks, maybe start building some stuff on it. So, real quick bio, we'll do this really fast. I don't want to spend too much time on this. My name's Kenny. I'm the developer advocate at the Stacks Foundation. I've been a full stack dev for about 8 years. about a year and a half ago, started getting really into blockchain. Web3, started building things on Ethereum and Solidity. And then I found Stacks and fell in love with it. And I'm going to go over some of the reasons why I did and why you might also be interested in building on it in this talk. So let's go ahead and get started by going over what Stacks actually is. So at a high level, what Stacks does is it allows us to build smart contracts for Bitcoin. And what that means is that a lot of the functionality that was previously unique to just Ethereum or maybe networks like Solana, we can now utilize with Bitcoin without actually changing Bitcoin itself. And that part is key. So Stacks is connected to Bitcoin with a consensus mechanism called proof of transfer. We'll go over this a little bit in more detail in a minute. And what it's kind of being branded as is a layer 1.5 blockchain. So Stacks is technically its own blockchain, but with this proof of transfer consensus mechanism, it cannot exist without Bitcoin. So that's kind of where the layer 1.5 comes in. In order for something to be a true L2, it can only perform the same functionalities that the L1 can. So like with Ethereum, the smart contract functionality, the fully expressive smart contracts and the programmability, they're built right into the layer 1, into Ethereum itself. And so L2s like Polygon, they can then take that same functionality and make it more scalable. Stacks is a little bit different than that. So the goal with Stacks is not to just take the same functionality that Bitcoin already has and duplicate it, or not duplicate it, but make it more scalable. That's more similar to what something like Lightning might do. With something like Lightning, you don't actually have any extra capability outside of what Bitcoin can already do. It just takes that same capabilities and makes it a little bit faster and more scalable. The goal with Stacks is to actually extend Bitcoin's capabilities and add capabilities to it. And so that's kind of where this 1.5 comes in. Something else I want to point out really quick, because this is often a point of confusion, is that Stacks is an open network. So anybody can run a Stacks node and verify the history of the chain just like they can with Bitcoin. It's not a federated chain. It's completely open and decentralized. A federated chain would be something like Liquid. And what a federated chain, the compromise there is it's not an open network, but that allows you to run a much faster network because the transactions are validated and managed by this closed network of people. But the downside there obviously is that it's not open and completely decentralized. So Stacks is open. It is a decentralized network. One thing I also want to mention really quick, because this is something that people often get stuck on, is you'll hear this language if you're in the Stacks world for any amount of time of built on Bitcoin. That can be a little bit misleading because it's not technically true. Stacks is, I would say, built for Bitcoin or built with Bitcoin, and it does leverage some of the security of the Bitcoin network, but it does not inherit all of its security. So this is a common misconception, is that Stacks is as secure as Bitcoin, and it is as hard to hack or fork or compromise Stacks as it is Bitcoin. That's not quite true. Because Stacks is its own separate blockchain, you could compromise Stacks without necessarily compromising Bitcoin. However, what it does mean is that because Stacks is connected to Bitcoin via this proof of transfer mechanism, and because it cannot exist without Bitcoin, that means that the entire history of Stacks, including any forks, have to be recorded onto the Bitcoin blockchain. So what we're really doing with Stacks is we are using Bitcoin as this broadcast medium. So every transaction that happens on Stacks has to be broadcast via Bitcoin. So while technically you could compromise the Stacks network without necessarily compromising the Bitcoin network, what you would have to do in this case scenario is you would have to broadcast that attack publicly on the Bitcoin network, which means that it only requires one honest Stacks miner to cut that attack off. And so that's what people mean when they say that Stacks inherits Bitcoin security or that it's built on Bitcoin. Just be careful that you don't take that too literally and think that Stacks is literally built on Bitcoin or in the same network as Bitcoin. It is technically its own separate blockchain, but it cannot exist without this proof of transfer consensus mechanism. And that's what we're going to go over a little bit more right now. Or excuse me, after we go over this, why build on Stacks? So we got into this stuff a little bit on the previous slide, but Stacks is built with Bitcoin, which means it extends Bitcoin's functionality and it uses Bitcoin as the settlement layer. So one really cool aspect of this is that Stacks actually has visibility into the Bitcoin state. And so what we can do here, and we're still in the early stages of this, but we're seeing more and more applications built utilizing this methodology and technology. But what we can do is we can actually enable dApps that use Bitcoin as currency. So because Stacks has visibility into the Bitcoin state, we can read that Bitcoin state and initiate transactions on Stacks based on what is happening on the Bitcoin chain. And so eventually what we'll be able to do is we'll be able to use Stacks as sort of an invisible programmable smart contract layer, but users may only ever have to interact with it using Bitcoin. So what they may do is they may initiate a Bitcoin transaction, which will then trigger a Stacks transaction, which will do some sort of logic on the smart contract using Clarity, the language we're about to go over, on the Stacks network. Behind the scenes, it will convert the Bitcoin to Stacks in order to use the gas token to actually run and fund the transactions just like we would on any other blockchain. And then on the other side of that, behind the scenes, it would complete the transaction, convert whatever action happened back to Bitcoin, and transfer it to the other person's wallet. So the goal here is that this really unlocks a ton of functionality for Bitcoin. Previously, Bitcoin was often seen as just a store of value, and so you couldn't do things that you could do on Ethereum with it. But now with Stacks, you are able to do those things. So one of the other things I want to talk about real quick is why. Why would we want to do that? Why would we want to separate those two things? So if you're trying to make a blockchain or a decentralized network sound money or a programmable system to build censor-resistant software on top of, those actually end up being two relatively different use cases. And so you want the blockchain to have certain qualities based on one of those two use cases. Ethereum can run into problems when it's trying to be both. And we hear debates about this all the time. Is Bitcoin sound money? Is Ethereum sound money? But the bottom line is that they're both successful. They both exist. Previously, it was only possible to build programmable things on Ethereum. So if you did prefer Bitcoin's consensus mechanism of proof of work, and if you did think that Bitcoin was a more secure, immutable blockchain, you still could not use that to then build censorship-resistant software on top of, or smart contracts on top of. So you had to do it on Ethereum regardless. Now, if you are of the mind, like I am, that proof of work is a more secure and immutable consensus mechanism, you still have the ability to now build programmable smart contracts and dApps utilizing Bitcoin as that final settlement layer. And so that's the sort of high level of why you might want to build on Stacks. And then again, that is made possible with this proof of transfer consensus mechanism. We'll go over that in just a second, but I do encourage you, if you're interested in it, some of the resources I have at the end really go deeper into that. It can be a little bit difficult to wrap your head around at first, but once it clicks, then you'll kind of realize how powerful it is, because it does allow us to connect into a more secure blockchain without actually having to change it at all, and inherit quite a bit of its security capabilities. And then finally, one of my favorite parts about Stacks is that they have the Clarity smart contract language. So Clarity is a language that was created specifically for Stacks. It took a lot of the common exploits and flaws that Solidity has, and it sort of built a smart contract language that was purpose-built to avoid some of those common flaws and exploits. So Clarity is designed to make it much easier to write safer code by default. And after we cover proof of transfer a little bit, then we'll switch modes and go and spend the rest of the time talking about this Clarity smart contract language. We'll give you the kind of the high level overview of what makes it unique, why you might want to build on it, and then we'll look at a really brief small code sample, and then you'll have some resources to go dig into it further if you would like. So this diagram kind of explains at a high level what is happening in proof of transfer and how Stacks actually functions and how the consensus mechanism works. So it starts with the miner, and that top left is the first step. So the way I like to think about Stacks is recycling the energy of Bitcoin, which is also something that's really cool, because a big concern with Bitcoin is that it has too much of an impact on the environment, whereas a blockchain that might use proof of stake uses less electricity. I'm not going to get into the proof of work versus proof of stake debate. That's a whole separate can of worms on its own. But the point that I want to make here is that Bitcoin does use a lot of energy. There's not really any way around that. People can debate the pros and cons of that and whether it's worth it. But what Stacks does is it allows us to actually recycle that energy. So at the bottom layer, you have Bitcoin, where you are exchanging a resource, in Bitcoin's case, energy. You're exchanging energy for Bitcoin. That's the proof of work. The proof of work that you're doing is you did this computation of this cryptography task. You spent the energy to complete the problem. You were rewarded with Bitcoin. Then Next level up, we have stacks in the proof of transfer consensus mechanism. So a miner mines Bitcoin, they have the Bitcoin, and then what they will do is they will then spend Bitcoin in order to mine stacks. So it's sort of one level up from Bitcoin. So this first step is the miner will spend Bitcoin, and then there's a verifiable random function that is weighted based on how much Bitcoin you actually spend, and that is what determines who wins the block and gets to mine it. And then what will happen is that miner, excuse me, stacks will take the Bitcoin that was put up as that the miner put up, and they'll transfer it over to stackers. And what stackers will do is they will lock their stacks into the network in order to boost its security, and they're rewarded with a large portion of the Bitcoin that the miner has put into the network. And so there's another consensus mechanism called proof of burn, which is similar, except that in that case, the cryptocurrency that you're using as the base layer is just burned and it's gone. In this case, the Bitcoin is transferred to other members of the ecosystem, in this particular case, stackers. So then that miner, after the Bitcoin transfer that they put up is done, they will then write that transaction to the Stacks blockchain and then receive the a portion of the newly minted Stacks reward, and then the transaction fees, and then the process starts all over again. So again, I have some resources at the end to dive more into how this actually works, because it can be a bit confusing to wrap your head around, but that's how it works at the high level. Let's quickly dive into Clarity with the last few minutes that we have, so I can go over some of the reasons why Clarity is unique and why you might want to write with it. So first big difference between Clarity and something like Solidity is that Clarity is interpreted and not compiled. So when you write a Clarity contract and then you submit it to the chain, it's getting submitted exactly as it was written. So it's not compiled to bytecode. So this has a couple of advantages. One, it just eliminates one more process that can go wrong. It's unlikely, but it's possible that there's a bug in the compiler. It's just another intermediary step that in Stacks is not necessary. And then the other major advantage of this is that by default, any contract that gets written to Stacks is human readable. With Solidity and Ethereum, that doesn't happen by default. The developer or the user has to go through an extra step to decompile that, and that's an external tool not built into Solidity and not built into Ethereum itself. It has to be created. So it's another third-party thing that is just an extra step that you have to do. And so with Clarity, by default, all contracts committed to the chain exactly as they were written, which just helps a ton with making everything more transparent and making it more readable. And then the second thing is that Clarity does not allow reentrancy. So Clarity considers reentrancy an anti-pattern, and it is disallowed at the language level. If you're not familiar, go ahead and look it up, dive deeper into it. But at a high level, reentrancy is where one contract can call into another contract before it's finished executing, and it can start this back and forth pattern to where somebody can perform a second action before the first action has been completed. And this has been the cause of a few hacks and exploits in the past. Again, it's something that has to be in Solidity on Ethereum. It's up to the developer, but Clarity does not allow it at the language level. Another feature of Clarity, another thing that it doesn't allow at the language level, is that overflows and underflows are automatically aborted. And so what this means is that if some function that you have in your smart contract generates a number that is either too big or too small for the language to handle, it will automatically abort. So that's not going to cause any problems for you. It's just going to cut it, and you're not going to, the function execution will end there, and you won't have to worry about that. One of the other cool things that we'll go over in just a minute when we look at the code sample are that custom tokens are built in. And so instead of having to use something like OpenZeppelin, where you have to create the actual tokens functionality in the token interface itself from scratch, these tokens are first-class citizens in Clarity. So we'll look at that in just a second, but there are built-in functions in Clarity to define like non-fungible tokens, fungible tokens, and so you can create your own fungible cryptocurrency tokens on Stacks, you can create your own NFTs on Stacks, and those functions are built right into Clarity. One of the other things is that Clarity is decidable, and so from the code itself, you can know with certainty exactly what the program will do. This has a couple advantages. One, it allows us to do something called post conditions, which we're going to go over in just a second. But the other thing you can do is that it's guaranteed that the program execution will end, and you can get an accurate picture of the exact cost that it's going to cost to process that transaction before execution actually happens. So this is pretty theoretical, so I'm not going to get into it now, but another thing to look up is decidable languages and Turing non-complete languages, which is what Clarity is, versus Turing complete languages. Solidity, for example, is a Turing complete language. So go ahead and look at the differences in that because it's really interesting and it's worth a look. But from a high level, the main advantages are that you can know exactly what the program is going to do just by looking at the code, and it's guaranteed that the execution will end, which on something like a blockchain, which is a globalized distributed network, is a really important feature to have. And again, that also allows us to do something called post conditions. So on the Stacks network, what we can do is if we're building a full stack dApp using Stacks, on the client side, when a user is initiating a transaction, we can put into the JavaScript, okay, once this transaction runs, these things should have happened, and if anything else happened, the transaction should be aborted. So what happens when a user will initiate the transaction? Let's say they're going to purchase an NFT and the NFT costs 10 stacks. There will be a window that pops up on their wallet that says, this transaction will transfer no more than 10 stacks from this contract to this contract, otherwise the transaction will abort. And if you were to try to initiate the transaction and somebody was trying to do something fishy and say double the stacks you were going to transfer, the smart contract function would just automatically abort, and the user would only be required to pay the gas fees to process that transaction. One more thing, the return responses cannot be left unchecked. So in Solidity, it's up to the developer to make sure they are handling any return responses. In Clarity, you cannot write a function without handling the return response, which just helps to make more functional, clean code that is less error prone. Another thing that makes it unique is its composition over inheritance. So rather than contracts inheriting from one another, developers instead define traits, which are then implemented by different smart contracts. So instead of having like a class-based system where a contract will inherit things from one class down to another, you can implement piecemeal traits and then your contract can interface with those. And the main purpose of that is to define standards. So like there's a good example is one for NFTs. There's an NFT trait, and by implementing that trait, you then go into your contract itself and you have to define these certain functions that do certain things. And that is to make sure that there are cohesive standards across public interfaces for different smart contracts. And then finally, went over this a little bit before, but it has access to the Bitcoin chain, which means that we can read the state of the Bitcoin chain and take action based on that. So real quick, I want to go over just a few lines of code to create an NFT in Clarity. This is just going to be super high level, super whirlwind, and then I'll give you some resources at the end. But this is the basic first initial amount of code that you would need to implement an NFT. So Clarity is a Lisp-like language, and so you'll see a lot of parentheses, which is weird at first, especially if, like me, you were used to languages like Solidity and JavaScript. It's definitely structured a lot differently, but once you start using it and it clicks, you realize how kind of clean and beautiful it is. So what we're doing here is we're calling a built-in Clarity function called define non-fungible token, fabulous frogs, and the identifier there is a uint. So just that one line of code created an NFT for us. And then down below, we're implementing another couple of built-in Clarity functions to mint that and give it to the transaction sender, to transfer it and send it from the transaction sender to another principal, which is another word for a contract in Stacks. And then we can also get the owner and we can burn the NFT. So these functions have built-in security properties so that you can't transfer an NFT that doesn't belong to you. You can't burn an NFT that doesn't exist. You can't mint an NFT that's not unique. So if the ID is already taken. And so these are some built-in security features of Clarity that just make it a little bit easier to write contracts like this. And then what you would do with something like this is you would then implement a trait which would allow you to create the public interface for this contract so that other people could interact with it in a standardized way. So that is the super whirlwind high-level overview of Stacks and Clarity. If any of this jumped out to you, if this was interesting to you, I have this page that I created of resources, stx.is/Web3Con-resources. So you can go there. You can check out, I've got some getting started tutorials on there. I've got some more information on Stacks and proof of transfer. So go ahead and dive in there, see what's interesting to you. I also have my Twitter link on there. So if at any point at all you have any questions, want to get involved in Stacks, need help, whatever, feel free to reach out to me on Twitter. My DMs are open. So thank you so much for taking the time to watch this. I know this was super quick and probably a little bit confusing, but if you dive into these resources and reach out if you need any help, I'd be happy to help you with that. Again, thank you so much for your time. I hope you enjoyed this, and hopefully I'll see you soon. Thanks.
This talk is sponsored by Radical. This talk is sponsored by Radical. Radical is This talk is sponsored by Radical. Radical is a peer-to-peer stack for building software together. Built on protocols instead of platforms, Radical provides creators with a secure and uncensorable code infrastructure, tools for collective code governance, and new ways to earn for open source work. Learn more at radical.xyz.
Hey everyone, I hope you are enjoying Web3Con so far. Uh, at the time of this recording, the hackathon is still going on, and I'm super excited about all the different teams who are building these awesome projects. And I can't wait to see those projects in action soon. Uh, but anyways, today with this talk, I'll try to share my open source software journey with Developer DAO and how it basically changed my career. Uh, so yeah, hopefully this will be useful to some of you. Uh, so let's just get started with it. Um, First of all, just a little bit of info about my background. Um, I'm a 21-year-old front-end engineer from India, and I'm now fortunately working full-time in Web3. I currently work for Missouri and the Moonshot Collective. Um, and at Developer DAO, I'm working on building Web3 UI, which is a React UI library for Web3 specific use cases. Um, and yeah, I love open source, and I'm all about building free open source software, and I'm trying to become a better maintainer each day. And today, hopefully, I'll share some insights on how developer DAO helped me become a better open source developer. So let's just get started. So before we talk about my Web3 stuff, when I made the jump to Web3, I wasn't totally new to open source software. I had already published some packages to npm. This one in particular, called React Link Preview, was did really well. It helped a lot of people and is used by so many people. It has around 50K downloads by now, which is insane for someone who's as new to the industry as me. Uh, but I had absolutely zero experience in writing code for Web3 apps. I did have a little bit of knowledge about how to interact with smart contracts on Ethereum networks, EVM based chains, but I had never really worked on a real project or made something like React Link Preview, which was used by someone at least, right? So that's basically what Developer DAO helped me do. Developer DAO helped me land gigs in Web3. It helped me build open source software for Web3. So yeah, I basically joined Developer DAO in September. Um, I had been following Nader for a long time. He I you I found out about him through his content about AWS and stuff like that. But I eventually got my first experience with Web3 stuff in 2020 through one of his tutorials. I went through the tutorial, I built the app, but I'd never really actually got into Web3 at the time. Of course, the hype wasn't as much back in 2020, so I continued working as a Web2 engineer and just freelancing basically. Uh, but as all of us know, in 2021, Web3 suddenly uh, grew in popularity. Everyone was suddenly talking about NFTs and DAOs, and DAOs really interested me. And that's basically when Nader tweeted about this new DAO called Developer DAO, which was supposed to be just an experiment, but it turned out to be just way more than that. This conference is proof for that. So yeah, I just minted that NFT because I trust Nether a lot. Um, and I just thought that why not? The NFT was free. I only paid the gas, so why not? And it was actually my first ever mainnet contract interaction. That's how unfamiliar I was with Web3 at the time. Um, but yeah, I just jumped into the DAO. I started talking to people. I made some new friends. And the first project that I worked on is the Developer DAO website project, which is basically the website you see at developerdao.com. It's very different now, but yeah, that's basically the first project that I got involved in. Um, at the time, we were mostly people coming from Web 2 into Web 3. None of us really had substantial amount of experience in Web 3. None of us really knew our way around. We just had these JavaScript skills, and we just wanted to build cool open source software together. So we started out by building a website for the DAO where people could just view their NFTs. It was pretty silly, but it was fun. As you can see in this screenshot, those are basically my first commits for the DAO. Um, yeah, that's how it started, and the DAO grew in popularity really quickly. Around December, all of the NFTs were sold out, and suddenly we had more than just like a Discord server. We now had these guilds. So we have one guild for development, one guild for community, for marketing, etc., etc. Um, so that's basically when I had the idea for this this project that I'm currently working on, which is called Web3 UI. It is basically a React UI library for Web3, as the screenshot says. Um, there are a lot of big changes coming to this project later this month, but up till now, I think we have made some really good components, which are definitely useful. But we have also learned a lot of stuff about just building a good UI library so that people can actually use it in their Web3 projects. So yeah, so I basically started by posting about this idea that I had on Twitter and in the Discord, and a lot of people seem to be interested in it. I received a really good response on the Discord. A lot of people were really excited about it on Twitter because they said that they had been looking for something similar, but there wasn't really anything. So yeah, I have been building this thing in public from even before it existed. um, and yeah, today it has around 450 stars, which is insane. And it, because it's still like solidly in development, it's not ready for use. It's probably not really useful in its current state, but we have learned a lot of new things. We have a lot of people have made their first contribution to Web3 via this project, which is worth so much more than just a few metrics. So amazing. And this project would not have been possible without all of these people who are as passionate about this project as me. Some of these people, especially Eric, Camila, and Nazi, helped me set up this project in the beginning. Also, a huge shout out to Withart and Yovi, who have helped me so much whenever I have had some issues regarding maintaining this project, and just some usual open source stuff. But yeah, if I had been working on this project individually, just as one person, I don't think this project would have still existed, because yeah, it's so much more than just me coding. Some of these people have worked on multiple components, uh, and all of us have been working on this asynchronously without ever meeting each other, even on Discord. I think we have only ever met once throughout these 4 months, uh, which I'm super proud of. We have managed to work so well asynchronously. I'm really proud of what we have built up till now, and we have so much more to build in the future. Mhm. So basically, what I have been doing during my time at Developer DAO, and what I want to continue doing is building free and open source software in public. The reason why I want to do this is, first of all, free and open source software is so essential in a decentralized world. In like, even if it's not a decentralized world, just like free and open source software is absolutely essential. I cannot stress that enough. I'm absolutely a maximalist in that regard, if you will. It it lets people build on top of what other people have built already. and that concept of having building blocks is just incredible. But doing that in public as an individual, in terms of my career, and also in terms of just working, is super helpful, because it lets me display or showcase my work to people on social networks like Twitter or on Discord, get feedback from them. It helps people notice me. It really helps with visibility for the project itself, and both for me as an individual. um, and it, of course, it's also a great way to get people to try your open source project and gather some feedback. So yeah, that's basically what I have been doing, and I highly encourage all of you to at least try doing this. I know that this building in public is not for everyone, and not everyone should force themselves to do it, but I highly recommend trying it. It can pay solid dividends for you, and just yeah, it just makes your life much easier as an individual dev in Web3. Um, One great example of how I have been sharing my work, and how Developer DAO has helped me do that, is tweets like this one. So I basically just made a quick GIF of this connect wallet button that we have. It's not actually visible in this particular screenshot, but it's like a 5-second long GIF which shows me writing code to display a connect wallet button. And Developer DAO basically retweeted whenever I tweeted something like this, and not only the DAO's account, but other members of the DAO also posted messages of encouragement. They provided feedback. They showed some love, and it was super helpful. And that's how a lot of people got to know about this project. Um, and not it wasn't like all just positive messages. Some people also gave me some useful feedback, so that was super nice too. So yeah, I'm super grateful that I get to build open source software in at Developer DAO. And I so the problem that so many open source developers have is that they build these amazing open source tools, but people don't even know that they exist. Developer DAO is like helping me solve that problem. It basically giving my work a lot of visibility. uh, since my work is totally free and open, uh, I need people to use it for it to have any actual meaning, right? If no one is using it, what's the point, right? So Developer DAO and everyone in the DAO has been super supportive, and I'm so grateful for all the support throughout. And one of the best moments of my journey building open source software in Web3 has been showing off Web3 UI to Austin Griffith. Austin is one of the OG educators in the Web3 space. I learned a lot about blockchains and Ethereum from his videos. He's the author of tools like Scaffold ETH, which is a huge inspiration behind for Web3 UI. And I actually got to show my project to him. He was super kind and he found it really cool, so he decided to make it a YouTube video, and it's now out there for anyone to see. Um, this wouldn't have been possible without a developer DAO, because the person who actually pushed me to do it was Ryan. A huge shout out to Ryan, coordinator. If you're seeing this, you are amazing. He pushed me to message Austin and let him know about this tool that I have been building. And yeah, he basically just did an intro uh, for both of us, and now we are here. Now I got to show my project to one of my teachers, and it was just like this too good to be real moment. But it was super nice showing it to him and gathering feedback from him, because he's so knowledgeable and so experienced in this space. So yeah, another thing that wouldn't have been possible without developer DAO. So of course I learned a lot of things about building open source software at the DAO. um, I did have some, like I said, I did have some experience building open source software before I joined the DAO. But after I joined the DAO, it just the level of experience that I have and the things that I know, I just didn't know that stuff at all before I joined. Some of that stuff is listed here. I'll just go over some of the important things. So one of the most important things that I learned while working on open source software at the DAO is how to document stuff and how important documentation is. Um, like I mentioned before, the entire Web3 UI team is based all around the world. We have actually never met synchronously on Discord apart from that one-off short call that we had. So we absolutely needed good documentation in terms of well documented issues, well written PR reviews, and just overall good communication on Discord as well. Uh, so that's something I had to learn really quickly, but I'm so glad that I did. And some of the people at the DAO who are extremely experienced in open source, they helped me learn all of this. So again, I'm super grateful that I get to be with all of these amazingly talented people who are always willing to share their knowledge with new people like me. One more extremely important thing that I learned while like building Web3 UI is finding the right balance between making something too opinionated and making something too flexible. So as when you are working on building a library, which is what we are doing most of the time when you are building open source software, you need to think about how people will use it, who's going to be using it, where they are going to be using it, and what level of flexibility and features they'll need. And this is an extremely tough decision to make. There are a lot of things that there are a lot of factors that decide what you go with. Um, I certainly got a lot of things wrong with Web3 UI in the beginning, but I think I learned from all of that and improved my decision making gradually. But and I still have a lot to learn. But some maintainers who are also DAO members, they helped me make these tough decisions. They also explained why they think I should make that decision. Um, so I'm again, I kind of sound like a broken record at this point, but yeah, I'm extremely grateful that I I get to work with these amazing people. I cannot stress that enough. And last but not the least, I learned about building free open source software. Um, I feel like I always had this desire for building free open source software, even when I wasn't into Web3. I had no idea that this entire world of Web3 even existed. But the the love for open source software inside developer DAO, and the amount of care that the entire DAO puts behind, just making sure that the people who are building these open source software are feeling good. uh, the DAO is always there to support people who are building this stuff. So I'm just so grateful that I have this environment where building open source software is the default instead of just spinning up a private repo on GitHub. It's just amazing to be in such a different space after having worked on shitty private code bases for almost 2 or 3 years. Before I end this talk, I want to give a huge shout out to two people. First of all, I want to give a huge shout out to Withart. Um, like the slide says, he's one of the kindest and the most talented person I've met in the DAO. Uh, he's a core team member at Developer DAO and also the Dev Guild leader. Um, he has worked at the Chakra UI core team. Of course, he's insanely knowledgeable about open source. He loves documenting stuff. Um, that's basically this is basically the person who taught me all I know about documenting open source stuff. And he's an incredibly good friend of mine, and I'm super grateful to have him alongside me at the DAO. He has mentored me as this new guy who just had this idea of wanting to build a UI library, but had no actual idea how to do it. He actually held my hand and actually helped me set up the project and publishing this to npm. So super grateful to Vithart for all he did for me and the DAO. And I also want to give a massive shout out to Yovi. He's also an amazingly experienced open source person. He has worked on the Preact and RQL core teams. And this Yovi always has an answer for any open source question that I ever had. If I ever had any questions about why my package was not working as intended, why something was not showing up on npm, Yovi was always there to answer those annoying questions for me, even when he didn't have to. And I just feel like everyone should have a person like Yovi alongside them when they are building something new, because having Withart and Yovi alongside me when I was still so new to everything, because remember, I was still new to Web3, and I was still new to actually maintaining an open source project. So I had to take all of this in, and these two people took some weight off of my shoulders and made me feel okay. Uh, so I'm super grateful for Yovi and Vithar. Both of you are amazing. So thank you. Thanks for taking your time out to listening to my talk. Hopefully it wasn't too boring. If you ever want to chat about anything that I talked about in the talk, or just in general, feel free to connect with me on Twitter. Um, and I go by the same username on GitHub as well. If you want to check out some of my work I've been doing, yeah, it was super nice having this opportunity to talk at Web3Con. So thanks to the entire team for giving me this opportunity and for organizing such an awesome event. And thanks to all the developer DAO members who have made the DAO what it is today. Um, I think we have done. I think we have come so far in just a few months, and just imagine how the things that we can do in the future. So I'm super bullish on developer DAO's future. Let's keep on building the DAO. Let's keep on building free open source software. I hope you enjoy the rest of Web3Con, and I'll see you soon.
Hi, my name is Nick Kalyani, and I'm the founder and CEO of Decentrology. And today, I'd like to talk to you about composability and how we are unlocking Web3 for JavaScript developers. Let's first start by talking about Web 2. In Web 2, the success was largely driven by the advent of APIs, application programming interfaces. For instance, if you wanted to integrate payment into your application, you would use Stripe, just a couple of lines of code, and you'd be done. If you want to integrate messaging, you'd use Twilio. Same with storage, you could use AWS, and mapping, you could use Google Maps. Of course, this led to an explosion of APIs, and there are now literally thousands of APIs to do just about anything you want to in Web 2 for your application. What this did is made Web 2 really open for developers. It became super simple to build applications, and developers could focus on the creativity and the actual use case of the application instead of solving all kinds of ancillary problems. Now, the nice thing about APIs is, even though it was open, because there were good standards around it, you could do this. You could build apps that integrated those APIs without compromising security. This was a really important thing because a lot of developers would not adopt APIs if they resulted in their apps becoming unsecure. What this eventually resulted in is the ability for millions of developers to unlock the opportunity of Web 2. And what that did was give them a path to income. So today, many web developers are able to build applications and make a livelihood just because they have access to these APIs, and they can take their craft, they can take the knowledge of JavaScript, HTML, CSS, and build fairly sophisticated applications. This is the power of composability. The ability of all these APIs to exist such that any developer with basic JavaScript skills can create very sophisticated applications is a huge unlock and makes so much opportunity possible. Now, let's look at what's happening in Web 3. In Web 3, there is a tremendous amount of friction for developers. And there's many reasons for this, but the main one is that in order to progress in Web 3, today, you need to know how to build smart contracts, which requires fairly advanced skills. You need to learn new languages like Solidity or Cadence or Rust or Go, and these are just really, really hard. In addition, you have to learn new programming paradigms. You need to think like a smart contract developer, which is very different from thinking like a web developer. You have to think about code execution cost, you have to think about security, and more importantly, you have to write this code and make sure it's secure from the get-go, because once you deploy it, it's immutable. You can't go and fix bugs. Now, you have to do all this in an environment where the code libraries, because of the nascent and fast-moving nature of the ecosystem, the code libraries are often broken. And to compound things, the documentation is usually incomplete or out of sync with the libraries. So this continues to add a fair bit of friction for developers. And even when you are successful in building smart contract code, what you end up doing is essentially duplicating code that's already been written by other people and deploying that. This is against the ethos of blockchain. The whole idea was that you wouldn't continually deploy the same code again and again. It's not Web 2 where there's lots of storage available for cheap. The storage is very expensive. And so when duplicated smart contracts are used, it's really very wasteful of resources. The other thing is, as developers who are just getting into this, who are learning how to build smart contracts, they're building these long monolithic smart contracts, and in the process, creating vulnerabilities, making insecure smart contracts. So this is another problem that developers today face. The biggest problem, I think, is also about smart contract discoverability. The fact that you have created a smart contract that solves a particular problem, it's on chain, it's available, but there's no way for me or any other developer to find about its existence. Maybe if you've written a blog post about it, maybe there's a link in there, we might find about it. But otherwise, it's almost impossible to find existing smart contracts other than the ones that are super popular. And this is all compounded with the situation around auditing. While there is auditing capabilities and auditors available for smart contracts, one of the fundamental problems is that the incentives are misaligned. Auditors today have no accountability. They charge a large amount of money for auditing smart contracts, provide a report, have the developers fix it, but then once the contract is deployed and a future vulnerability is discovered, the auditors have just no accountability at all. So this is a fundamentally broken model. All of these together, all these factors together have created a problem of adoption. Web3 adoption is slow by developers because of all these problems, and we need to fix that. And that's what we are doing at Decentology. Our solution consists of taking the fact that there are a few contract developers who have these advanced skills. So if you look at the broader market, there's a lot of developers who are coming into this marketplace, but there's a few that are already there, who've been there from the beginning, and who have advanced skills. So what we want to do is leverage these skills. And what we want to have these developers do is, instead of working on creating monolithic smart contracts, instead create smart contract code that is modular. And in doing this, we also want them to have some standards where they can build in discoverability into these modular smart contracts using metadata. And we want to create a model where auditors are accountable for their work. So they literally have to audit work and stake tokens, stake money, indicating the confidence and trust they have in the code, so that if there is a problem that's discovered in the future, then that money is slashed, that stake is slashed, causing them financial loss. This aligns the incentives between the developers and the auditors. So finally, what we want to do is bring to Web3 the Web2 concept of APIs. As I mentioned earlier, APIs were really very successful in causing an explosion of application development in Web2, the likes of which has never been witnessed before. And we want to reproduce the exact same thing in Web3. Our solution is smart modules. So let's look at what that actually means. So the idea is that instead of developers creating smart contracts that are entire applications, build them as smart modules, which are smart contract building blocks. So each smart module does one thing really well. So if this sounds familiar, it's because it is. So if you look at APIs in Web2, most APIs do one thing really well. And if you want to do something else, you use a different API. So if you bring that model to Web3, that equivalent would be smart modules, which are on-chain smart contracts that are essentially building blocks. So what this can do now is open up opportunity for millions of JavaScript devs and give them the same ability to grow and flourish and thrive in Web3 as they did in Web2. The ability to build decentralized apps that are very complicated does not have to require advanced smart contract skills. We believe that it is possible for JavaScript developers with the skills they have to build complex apps and keep the development process very simple. So you don't have to learn these new languages. You don't have to learn new programming paradigms. You can stick with what you know and continue to have a simple development process, yet build very sophisticated applications. And that's the platform that we are building. And ultimately, we want to make sure that the applications you build are also very, very secure. And that's part and parcel of what we are building into our platform. We want to make sure that the ability for that Web2 unlock for a lot of developers to earn income is also available in Web3. We want to make sure the opportunity that exists for developers with the skills they have with JavaScript to earn a livelihood can be replicated in Web3 also. This is the power of composability. We want to unleash the power of composability that led to so much success in Web2 in Web3. Our solution is called the Hyperverse. It's an open marketplace of community-built, audited, and easy to discover smart modules. So what it does is essentially make it super simple for Web2 devs to build apps without writing a single line of smart contract code. Let's see how that works. So it starts off with the small number of developers who are experienced with smart contract code to build smart modules. So as I mentioned earlier, instead of having smart contracts that can do lots of things, smart modules are single-purpose smart contracts. They're on-chain, they're available, they're deployed, and they're ready to use. They're analogous to APIs. So smart module developers build these, and then through a community of registrars, they validate the packages that have been built. For example, we want to make sure that a smart module has the correct metadata for discoverability, that it has documentation, it has examples, it has usage and reference information, and all of those things together to make sure that the package is usable and complete by other developers. Once that's done, then a community of auditors starts taking a look at that code, and they look at the code for security, for vulnerabilities, etc. And if they feel that the code is secure, what they will do is stake tokens as a form of their trust and confidence in that module. This, in effect, acts as an insurance layer for these smart modules. So this has never existed before, and it's a great innovation that we are really, really excited about. The ability to have insurance on open source software and make it so that anyone using this software can trust it. So once this is done, these modules are on-chain. They are available on different blockchains. Hyperverse is a blockchain agnostic platform, and so for different blockchains, there will be different sets of smart modules depending on the use cases that are prevalent for that particular blockchain. But ultimately, the Hyperverse is about a collection of on-chain smart modules that have been reviewed, that have been created by experts, and that have been audited and are secure. What does this result in? Well, it makes it super simple for JavaScript developers, because now with all these on-chain modules, it becomes a simple task for us to create a JavaScript wrapper in React or in other frameworks that allow you to essentially use these smart modules on-chain as if you were using JavaScript modules. In fact, when you experience the Hyperverse software, you will see that it's exactly like that. It's literally NPM for smart contracts. We've made it so easy that you don't need to learn any new programming languages. You work with a familiar paradigm of NPM, you add JavaScript modules, and all the hard work is done for you in terms of integrating with the blockchain smart contracts. It's literally taking JavaScript modules that have connectivity to on-chain smart modules and using them like Lego blocks to build sophisticated applications. You don't need to learn anything new about how to build for Web3. You have all the skills already present. In fact, if you were to make an analysis of the market, our guess is that roughly 20% of the developers in the market will end up writing smart modules because they are familiar with Solidity, Cadence, Rust, TypeScript, etc. But a vast majority of you, approximately 80%, already have the skills. You'll just be building client applications using HTML, JavaScript, and CSS. And this is the huge unlock that Hyperverse is bringing. We are just getting started. Our mission is to onboard 10 million developers to Web3. We have now created a preview of the Hyperverse. We've got a few modules going, and we have a large number of bounties available for experienced smart module developers to build these smart modules so that the JavaScript developers can start building applications at scale. We are working across multiple blockchains, including Flow, EVM blockchains like Ethereum, Metis, Avalanche, Polygon. We'll be adding Solana and other blockchains. Our goal is to be the dominant way for developers to build for Web3, and we welcome you to join us on this journey. You can start building at decentology.com and join us in our community on Discord at discord.gg/decentology. Welcome to the Hyperverse.
This talk is sponsored by This talk is sponsored by Hedera. Runs Solidity smart contracts, manage tokens, and
care about it. And
this talk is This talk is sponsored by Hedera. Runs Solidity smart contracts, manage tokens, and log immutable data using hashgraph consensus to reach finality in seconds at a fraction of the cost of blockchain-based alternatives. Learn more at hedera.com.
hello, everybody. Thanks for coming to listen to my talk. I'm going to talk to you all about maximal extractable value. This concept has been poorly misunderstood at large, I think, by the greater industry. And so I'm really excited to kind of clarify this term and why people should care about it, and what are some of the positive implications as well as some of the negative implications. So before we get into it, just a little 30-second intro on me. My name is Waylon Jepson. I'm a graduate student at Colorado State University studying computer science. My undergraduate degree is in mathematics, and I'm doing research on modeling discrete event systems with tropical algebra and consensus stability in distributed ledgers. And part-time, I work doing developer advocacy with Hedera, where I help people learn how to use the Hedera services. So let's see if I can get to the next slide. So the goals for this talk are going to kind of introduce MEV and see what sort of constraints we can define MEV within, and then talk about why MEV is important, talk about which platforms are affected by MEV. There's a lot of ambiguity, I think, here. And then I'm going to present some of the open research questions. And I'm actually collaborating on a bunch of these research questions with my university. But if you're interested in any of these research questions, definitely feel free to reach out to me. There's a wonderful community of people in industry and also at academia that are working on some of these problems, and we are always needing more bright minds to look into some of these open questions. So what is MEV? So I think one of the reasons MEV is kind of misunderstood is because its acronym actually changed halfway through. It used to mean minor extractable value, and then it was changed to maximal extractable value to encompass larger financial systems. So this is a very encompassing term. MEV does encompass a lot of different activity. But more generally, it's classified as any value that can be extracted by transaction ordering mechanisms. So in the last year on the Ethereum network, there's been about $800 million in USD extracted in MEV in the past 2 years. And so this is a lot of money. You've probably heard of a lot of people that like quit their jobs to go look for MEV and try and extract MEV from different distributed ledgers. This has kind of been a really big honeypot for a lot of engineering talent or those just inclined to learn. And I think this has actually been really good because a lot of people are now financially very incentivized to learn about how to write smart contracts and learn about using the Ethereum virtual machine and how to interact with different opcodes. And I think that has been good. There's been a lot of people that have cultivated a lot more deeper understanding of the technical tools in our industry because of this, which is an overall positive thing. So here's a little bit of well-known types of MEV. So if you're familiar with decentralized financial protocols, lending protocols allow you to deposit collateral and borrow against this collateral. One of the most popular lending protocols being Aave. However, there are others like Rari Capital, MyFinance, and they all vary a little bit in kind of their design. But one thing they need to ensure is that these loans never become under collateralized, right? Because if you have a default loan, that's a big risk. You know, this is what happened in the 2008 financial crisis. So to ensure that their protocols are sustainable, they actually incentivize other people with rewards to recollateralize under collateralized positions. And this is called liquidating. And as a result, people can make good money liquidating under collateralized positions. And this is a type of way that you can extract value through different transaction ordering. And so liquidating people is actually quite competitive. And most of this is all done through automated processes. People build bots to do all these things and try to optimize these bots so that they do them faster and they compete with each other. And we'll get into some of the game theory of that competition in a couple slides. So liquidations are overall really important. Of course, you know, it's not a good thing to the person that got liquidated because it's at a cost to the person that got liquidated, but the liquidator does receive money. And you know, regardless of, you know, how you feel, you don't want to get liquidated. Nobody wants to get liquidated, but you can totally mitigate your risk. And in volatile markets, like, you know, if you have enough bandwidth, you can be pretty diligent about not getting liquidated. It's generally people that are careless, but also big market fluctuations do sometimes happen in this industry. But it's very important that these loans remain over collateralized. So liquidations are overall a really important thing, negatively impacting the person that becomes under collateralized and positively impacting the liquidator. So another type of MEV that's pretty well known is front running. Front running is basically the act of viewing transactions in the public mempool and seeing ones that you could copy and pay a higher gas for and receive the profit that would be the result of that existing transaction. So I think one of the first examples was the birthing of CryptoKitties, where the birthing transaction of a new kitty had a unique hash where if submitted to the right contract, it would return a kitten, a new CryptoKitty, right? And so people would see this and they would front run these kitties by copying this transaction with the unique hash, so they actually got the kitten. And the people who actually birthed the cats and put in the work on the different, fertility time clocks that have to do with CryptoKitties didn't actually receive the cat. And so these users, of course, were upset about this. Nowadays, there's some mechanisms in place that you can use in your development processes to stop things like this from happening. Another type of MEV is arbitrage. So arbitrage is defined as capitalizing on price discrepancies in different markets and market inefficiencies. So if an asset is sold at a high price here and a low price there, you can buy at this high price and sell at this low price. Usually these are on two different decentralized exchanges. However, there is arbitrage across centralized exchanges and decentralized exchanges, and even across multi-chains. And arbitrage is widely considered a very good thing and actually quite necessary for financial markets to be efficient. And the reason for this is they drive a price equilibrium, which is always going to give the end users the best price for their assets. Another type of MEV is a sandwich attack. So a sandwich attack is where you sandwich a user's transaction between two transactions, usually leveraged with, say, a flash loan with a large amount of volume of an asset, so that the price of an asset either inflates or deflates before and after, and then you capitalize on the discrepancy here. And this has a negative impact on the users that are sandwiched. And actually, this is probably one of the types of MEV that is most looked down upon, because it's just kind of mean. It's kind of at the consequence of the user, where the user is getting the worst possible price for their trade. And I actually don't know very many searchers that actively orchestrate sandwich attacks. I think in the searching community, searchers are people that look for MEV and capture MEV. Most of them do have some ethical bounds and are not always looking to sandwich attack. And then there's a very, very long tail of niche MEV, and you can imagine you can be incredibly creative and find ways to extract values from different blockchains. And so this is kind of where a lot of people try and figure out different ways to do this. There's stuff that people do with index tokens. There's cross-chain MEV. So these are some of the well-known types of MEV. So hopefully you have heard of some of those, and maybe now you have a better perspective on those. So when these bots called searchers, the people looking and searching to capture and extract MEV, compete with each other, there's a game theoretic model that's played. It's played by the searchers and the validators. This is particularly in the Ethereum blockchain, right? And so the miners on the Ethereum blockchain, they're responsible right now for ordering transactions. And, they do so in the order that is most profitable to them. So they will order them into the degrees of how much gas fees have been paid for this transaction. If one has been paid with a very high amount of gas fees, they'll put that one at the top because the miner makes the most money from processing that transaction. And they want to make the most money from processing the block as possible. Now, the searchers express these ordering preferences with the transaction fees, but they actually compete with each other, and so they result in bidding wars. So some searchers maybe identify the same MEV opportunity, and they compete by increasing the fee for this transaction so that they'll get it with other searchers. And this is actually called a priority gas auction, where these searchers kind of try to outbid each other. And this happens until the auction is either won or is no longer profitable. So there's actually a really amazing paper if you're kind of interested in MEV. Is kind of the first paper published in an academic journal on this sort of phenomena in distributed ledgers. It's called Flash Boys 2.0. And in this paper, they actually illustrate a Nash equilibrium for these priority gas auctions. But let's go next. So next, why is MEV important? So the big, of course, there's different parties that are affected, right? If you use decentralized financial protocols, you want to be aware of like, oh, like maybe it is possible that my transaction could be front run, or like I know what a sandwich attack is and what the risks are there and what makes me most vulnerable and maybe how to avoid that. So it's good to know those things, and that's one reason why you should care. But I think the primary reason that a lot of people care and why Vitalik has actually been active in the MEV community is because there is a potential valid attack on the consensus stability of Ethereum. So if you aren't super familiar with the way Ethereum work, it uses probabilistic consensus. So that means after a certain period of time, there's a high degree of likelihood that your transaction is final, right? This is why you wait for a certain amount of block confirmations after you submit a transaction before your transaction is perceived as valid. However, if an entity were to identify a block in the past, not short amount in the past where you have like uncle blocks and a lot of ambiguity of the longest chain, and that's why you wait a certain time to find the longest chain to develop. But a block kind of far in the past, like maybe say like 15 blocks in the past, maybe longer even, right? And somebody identifies that if they were to order the transactions in that block differently and maybe include different transactions than the ones that were included in that block, they would make an incredibly large amount of MEV. So if somebody does this, and if that value, that monetary dollar amount of that value that they could extract is greater than the cost of resources to go back to that block and mine a new longest chain from that block, this would be a valid attack on the consensus stability of Ethereum, right? Somebody would basically go back in time and create a new longest chain from this block. And you're like, well, that sounds like that would be really ridiculous, right? Like it takes a very large amount of computational resources to make a longest chain. And, this fact has kept Ethereum quite secure for some time. However, it was actually shown in the Flash Boys 2.0 paper that with empirical evidence that this is actually a valid attack. And there actually is that large of quantity of MEV to be extracted from blocks. And so not only is this people financially incentivized to orchestrate this attack, but there's enough financial incentives here to cover the cost of orchestrating this attack as well. And so this is kind of the primary concern. This is what everybody doesn't want to happen. We don't want this to negatively affect Ethereum's consensus stability. Another reason why you should care is because some other negative externalities here are censorship and collusion, right? Like we really want distributed ledgers and Ethereum to be open public networks that are transparent and available for anybody to use, right? Well, you can imagine that maybe if bot searchers compete so aggressively, they create kind of a state bloat and they drive up the gas prices for regular users, making gas prices really high for regular users. There's also, one can imagine that you can derive a cost of censorship, right? Like how much money would you have to pay in transaction fees and individual transactions to have all of the block space to yourself and not let anybody else have any of this block space. These are kind of the questions and problems that make MEV really relevant and are some of the problems that people want to mitigate. So let's take a look about what is Flashbots. So Flashbots is actually a research and development organization that's sole purpose is to mitigate these negative externalities of MEV. So they aim to bring transparency to MEV activity, democratize access to MEV, so reduce the barrier to entry, and enable fair distribution of MEV revenue. Now, these are kind of ambitious goals, but I think they are very noble values. And I actually quite admire the Flashbots organization and think they do a lot of really, really great work. So the first product that Flashbots actually released is something called Flashbot Bundles. And what the Flashbot Bundles are is they allow people to group transactions together where they are executed deterministically. So you won't have half of your transactions executed. You will just have either your entire bundle executed or not. And this reduces some barrier to entry because this way the profit of the entire bundle is evaluated rather than the individual transactions. So you can actually start the transactions in your bundle and not pay anything for those transactions if overall the final execution of all of your transactions does result in profit. So this reduces maybe some startup capital that might have previously been necessary for transaction fees, not a lot for searchers or people to start searching. But another thing, and probably the more important thing that Flashbot Bundles does, is it actually migrates the priority gas auctions off-chain. So the Flashbot Bundles are actually submitted via a private relay to miners that run a modified Geth client called MEV Geth. And it just allows the miners to accept Flashbot Bundles. And this is good for two reasons. It actually reduces state bloat of the chain, and it actually doesn't universally increase the gas fees for all the other users as the result of these auctions, which is really nice. So this way, users aren't negatively impacted by these priority gas auctions, these kind of aggressive bidding wars between searchers, and users can still have maybe a little more reasonable transaction gas fee. So bundles produce some user transaction privacy, which is also interesting. These transactions don't actually go through the mempool. So if you've been following Flashbots, you know that some decentralized exchanges actually started using this as a way to protect users' transactions from getting potentially front run or sandwiched. So this is another application of using Flashbot Bundles. And I think the way they do this is they call this product, when they use Flashbot Bundles this way, they call this Flashbots Protect. So Flashbots works in these three areas of auction design, data, and research. So next I'm going to kind of summarize some open research questions here, and then I'll wrap things up. I don't want to go too far over time. If you do have more questions about this or want me to clarify anything that I've talked about, feel free to DM me on Twitter. My handle is 0xjepsen, that's Jepsen. And I'll do my best to also make these slides openly available to people and any other resources that I have and can provide as well. So let's dive into some of these research questions. I'm probably going to go pretty quickly over these. One research question is auction design. Do we know if the priority gas auction is the best auction design for these searchers to compete their bundles with? Maybe, maybe not. Should we provide additional crypto economic incentives in these auctions? And what should these auctions demand from all of the participating actors? So there's a lot of need for people to do analysis and objectively study different auction mechanism properties to identify what the best auction design for these searchers to participate in would be. Cryptographic privacy is also another issue here. So currently when you submit a bundle to a miner running MEV Geth, and by the way, more than 50% of miners run MEV Geth right now. So there's been a huge adoption by the validators in the Ethereum network of the MEV Geth client. This is very ubiquitous, and they're financially incentivized to do so, right? But miners currently do have the ability to unwrap a bundle and look at transactions and accept and take all of that value for themselves and giving none to the searcher. Now, one could argue there is a little bit of crypto economic incentive in place in the sense that identifying MEV opportunities is challenging, and the miners wouldn't want to jeopardize the relationship they have with searchers, where the searchers identify the MEV and then give the miners a cut for helping them capture the MEV through transaction fees or tips. One can think of them as like bribes as well. So there's some work to be thought about on enabling privacy of searchers, like these searcher miner privacy. There's been some initial work done here with the use of secure hardware enclaves. Although hardware enclaves are kind of controversial, you have to depend on proprietary hardware, and this is generally not something that's preferable to cypherpunks and people that care about privacy, and they don't like depending on proprietary hardware. However, this is a hard problem. The question here is, can we apply different cryptographic primitives to ensure this privacy guarantee? And then same problem, but should we use economic incentives and define different incentive mechanisms to preserve this privacy? Another open research question is, we all know that Ethereum is planning to migrate, and I know it's no longer called ETH2, but it will be migrating to proof of stake. And the question here is, what does MEV look like in this evolution of Ethereum? And there has been some work done here, but basically the questions here is like, we don't want to create kind of this economic gravity, this centralizing force, right? We want things to be fair for all validators. And actually, I think some of the most recent work Vitalik has been participating is there's this work in separating the entity that orders transactions and the entity that validates transactions in this block proposal model. And this helps mitigate some of the concern around the consensus stability problems here. But there's some resources here, and there's some at the end of the slides as well on this research question. Also, another open research question is, what does MEV look like in layer 2 protocols? What sort of transaction sequencer mechanisms to protocols like Polygon, Arbitrum, Optimism, Starkware, what do they use? And whatever they use, how does that affect the capture of MEV? I know there has been some evidence and searchers that have captured MEV in Polygon. MEV is widely be considered very ubiquitous and not something you can actually ever get rid of. And actually, there is a ton of MEV in traditional financial systems as well. This is what high-frequency traders capture when they make money. In fact, there's a whole book on it. It's called Flash Boys, A Wall Street Revolt. And if you're interested in MEV in traditional finance, I recommend that book as well. But it is a naive thing to do to claim that there is no MEV in a protocol. And I've seen a lot of people claim this, and it's kind of silly, because you actually do want some MEV, like you do want arbitrage, right? You want your markets to be efficient. But there are good kinds and bad kinds of MEV. I think what a lot of people often conflate is they confuse MEV for just front running. And that's not quite accurate. So then there's taxonomy, and there's been a paper called Clockwork Finance that has done some initial work on this, additionally with the other paper, Unity is Strength. But the idea here is we want to build a robust theoretical framework for quantifying and analyzing different aspects of MEV. There is account abstraction. So actually, Vitalik suggested you could use Flashbots as account abstraction. Account abstraction is the idea that transactions don't originate from an externally owned account requiring an elliptic curve digital signature, but instead they can originate from like maybe smart contracts. So some applications here are like smart contract wallets, like Gnosis Safe, where these are multi-sig wallets. Um, there are some cryptography research questions here around distributed key generation and arbitrarily weighted signatures that are all cool research questions to get into if you're really into math and cryptography. And work here could have impact and maybe better social recovery wallets. I think there's a lot of engineering work to be done here on making kind of things like social recovery wallets more user-friendly and accessible and easy to use. Protocol design is another big research question here. This is basically investigating the design principles of consensus protocols, but also the design principles of different DeFi primitives, like decentralized exchanges. Like, how do these constant function automated market makers or bonding curves or different concentrated liquidity provisioning models impact MEV, right? There's a pretty cool project out here called Primitive Finance, in which they are actually not using oracles. They're actually using their CFAMMs as price oracles. And this is similar to Uniswap V2, but one thing they do is they have different concentrated liquidity strategies that are allowing people to do rather than just one XY equals K liquidity curve like Uni V2, which is beautifully simple and not very computationally demanding, but the cost there is that the users are subject to slippage, which does have an impact on MEV. So these are some of the research questions here, like how do we design protocols with this in mind to build a better quality of service for users? Search optimization. A lot of searchers that are looking for MEV have actually done amazing work in this. However, most of it is kind of a trade secret, right? Because if they were to leak how they're optimizing their bots to be faster and do better searching, they would be basically giving up their competitive edge against other bots. But there's a lot of opportunity to do work in search optimization in this domain as well. I'll skip over this one just because I want to be able to be done by 30 minutes, keep things pretty concise. Of course, MEV and other protocols is an open research question. Do deep reorgs happen in other protocols? Is that a valid consensus stability concern? And if not, what are the dominant MEV strategies in other protocols? There's been evidence of searchers in some other protocols doing quite well financially. So what does that look like? How can we democratize and bring transparency to this activity? And then that's about wrapping it up. If you have any questions on this, definitely feel free to reach out to me. I know I put a lot of information on this slide, and I know not all the topics here are trivial, but always happy to talk more about this. And I'm actually working on some papers through my university on this, so would love to talk to people about MEV.
Hi, everybody. Hi, hackers. My name's Abby. I'm the head of community at Radical, and I'm joined here today with Cloudhead, one of the co-founders of Radical and lead of the All Clients team. And we're here to give you a quick presentation on Radical, what it is, why it's cool, and give you a demo of one of our latest feature releases, the Radical CLI. So hopefully you all can get hacking on the Radical network. So to start, I want to just give a quick intro on Radical for those who aren't familiar. So Radical is a lot of things. Radical project is building secure and uncensorable code infrastructure, collective code governance, and new ways to earn money for open source. Today, we're going to be focusing on the first value proposition that Radical offers, which is sovereign code infrastructure. So basically, Radical enables developers to securely collaborate on software over a peer-to-peer network built on Git. So this is cool for a lot of reasons. At the core of Radical, behind all of our Ethereum features as well is a really powerful peer-to-peer network that's powered by seed nodes that operate a gossip protocol that's built on top of Git. So what this does is it replaces the centralized forge. It provides an alternative for the centralized forge model that we see in our day-to-day use of GitHub and GitLab. So it allows us to collaborate on software without relying on central servers, which allows us to collaborate and host code that is uncensorable and untakedownable and outside of any platform. So the cool thing that we'll be showing today is that you can actually do all of this from your command line from the CLI. So unlike centralized forges where you have to rely on UIs or web experiences, Radical is something that you can interact with and publish to via the command line, making this a more local first experience. And then finally, the power of Radical is that allows you to own your identity. It allows you to have a self-sovereign developer identity that is platform agnostic. It's not defined by email addresses. It's defined by cryptographic key pairs. So the cool part about Radical identities, which you'll be learning about how to create today, is that you can actually link them to your Ethereum identity via ENS and create a global developer identity that's based in your local environment, the keys that you use to publish and collaborate on code repositories via Git, and also your identity in the Ethereum world. So I think that this is a really cool demo that we'll have today. It'll walk through how to get started on the Radical network with an identity and how to collaborate and publish code to the network. So without further ado, I'll pass it off to Cloudhead, who built and designed the CLI, and he'll give us a run through of the product and give us a demo of the CLI as a whole.
Hey, what's up? So let's get started with the CLI. So first thing is you're going to want to head up to radical.network and click on get started. And then on here, you have some install instructions. If you want to build from source, if you already have Rust installed, then that could be the easiest. Otherwise, on macOS or Homebrew, we have also a package which only works on x86-64 right now. So if you're on the M1s, you have to know what you're doing. So I'm going to basically follow this guide more or less, but I'm going to show you in the CLI so that you can see this whole thing happening live. So I'm just going to switch over. All right. So, okay. So here I'm in a, I'm just in a folder for the conference, and I have the Radical CLI installed, and basically it's a set of tools that all start with rad, including rad itself. So if I enter this, I can see a bunch of commands, and it also tells me, okay, it looks like it's the first time you're using Radical. Start with rad auth to authenticate. So I'm going to do that. Do rad auth, and it's going to ask me to create an identity. And so these identities are completely local. So this is not publishing anything on the network. This is just creating something locally. So I'm going to put a username. I'm going to enter a passphrase, which is to protect my key pair that is being created. And so it's telling me it's creating an ed key pair, and this is what we call the radical key pair. It's SSH compatible, so you can also use it to log in and do things like that if you want. And with recent versions of Git, it's also possible to sign commits with this key pair, so it's quite handy. There's a few things you're going to need, like SSH agent, but the tool will tell you if you're missing something. And then what this tells me is, so the most important thing is that I have a peer ID, and this it tells me it identifies my device. So this physical device I'm running on is identified by this ID, and this ID is really just an encoded public key. And then I have a URN, which is another ID which identifies me as a user, so across devices, right? Today we're mainly going to focus on the peer ID because I have only one device, so there's really not so much use for the URN at the moment. If I do rad self, I can see who I am, essentially. So name, URN, peer ID, and then here you can see the keys in SSH format, which are also handy for authentication. And so the next thing it's telling me as a hint is run rad init from a Git repository. So I'm going to do that. I'm actually going to create a new Git repository because for the demo, I think it makes sense. So I'm going to say, I'm going to create a Web3Con repository. I'm going to do this. I'm going to do git init. I'm going to add a file, Web3Con, and I'm going to add it. And sorry, I have the G is Git. I just have it aliased in muscle memory. So let's just say initial commit. All right. So I have this Git repository, and we have one commit in it. It's essential to have at least one commit for a radical project to be created. And so the next thing we're going to do is called rad init, which will initialize a radical project. And so just like user identities, radical projects have identities that are sovereign, that are portable and offline first. So this is important because a Git repository on its own doesn't really have an identity. You can't compare two repositories unless you just compare the files. But what Radical is going to do here is it's going to create a unique identity for this project with some metadata. So I'm going to type rad init, name Web3Con, that's fine. Description, Web3Con demo, and then default branch. So whatever branch you're on is going to be set here, but you can of course change this to whatever you want. So one thing it's asking here is whether you want your radical signing key to be configured in the checkout. And this is really cool because, so I'm going to say yes. And what this is going to do is it's going to configure it as a commit signing key. Now, if you already have a commit signing key and you don't want to do this, you can always say no. But if you don't, I would highly recommend it. So it's telling me now, okay, your product ID is na. You can do rad dot to show it from inside the project, indeed, and then you can publish with rad push. So far, everything we've been doing has been offline. One thing I wanted to show with this signing key is how it works. So what we do is essentially only in the local repository, we configure a few things. Here we configure the signing key, so which means that if you're signing commits in here, it'll use your radical key. And we're using the SSH format, which it's a bit confusing because it says GPG format SSH, so essentially it's not using GPG for signing. It's using SSH. And this is nice because the SSH keys are much smaller, and SSH is just better than GPG in a lot of ways. Let's give this a try, actually. So I'm going to edit the README, and I'll just duplicate this, and I will commit, and I'm going to say, well, actually, I can just, yeah, I'm just going to, so this is commit. I can commit, and now I'm going to git log show signatures, and you'll see that the original commit I did was with my sort of default key on this machine. It's a good signature, but it's red because it's not trusted. Whereas this second commit I did here, same same message, but essentially it matched what they call a principal, which is just a key that is recognized and trusted. And you can see my peer ID here, and then the SH key. And so this is my radical peer ID. And the reason this key is trusted is simply because it is in a file called git signers, which is by default not checked into the repository. So essentially, we add it for you in git ignores, but you can also check it in if you want to have a key list in your repo and sort of verify that all signatures have been made by trusted keys. So now that we have all of this, I'm going to publish the project to the network. And there's a couple of ways to do this, but the simplest is via rad push. And one thing you'll notice is that if I do git remote, there's actually a rad remote that was created when I initted the project. And this is actually a remote that lives on the device, on my local device. So it's actually a remote that is in another repository on the machine that sort of contains all of the radical state. We call it the monorepo because it has all radical repositories namespaced under a single Git repository. And so when I push, if I just do a git push rad, this will push from my working copy here into that monorepo. But still, this is not publishing to the network. I can actually do this, and you'll see it's instantaneous because it's completely offline or local. If I do rad push, however, what happens is that it's going to do a git push rad, but it's also going to synchronize the changes to a remote seed node. And currently we have 3 seed nodes deployed ourselves. So the Radical project has deployed a couple of seed nodes, but anyone can deploy a seed node and use it to push and pull from and collaborate with. So since it's the first time I'm pushing, it's going to ask me, so you see here, it does a git push rad, but this is already done. And the next thing is, since it's the first time I'm pushing or publishing to the network, it's asking me where I want to publish. And I have 3 options here. These are the kind of default seed nodes that are configured. But again, you can overwrite this and publish to whatever seed node you want. All right, so here we can see that the project was pushed, and then it synchronized to the seed node that I selected. So you see here, syncing project to pine.radical.garden. And then it tells us that the project is available on the web for browsing. There's a few different URLs that I'll explain. And then one important thing is it tells us also that the seed configuration, so the fact that I selected Pine, was saved in my local git config. And you can see this if you do git config rad.seed, it'll tell you Pine. And so this is just stored inside of Git itself right here. All right, and it's also telling us that if we want to override that, so we want to sync to a different node, we can just pass the seed argument to push or to sync or to whatever command that takes that. It also tells us how to change it more permanently. So every time you are interacting with a project on Radical, there's going to be a seed node that is implied, essentially. And if there is none, it'll ask you which one you want to push to, or it'll ask you to select one. And so if we do rad push help, we'll see here, that you can pass a seed. And so this would basically look like this. Let's say I wanted to push to a different node. I would do something like this, for example. So just the host name. Cool. So now that we've done this, it might be a good idea to check out what was published through one of these URLs. So just to kind of explain this briefly, the two web URLs, the first one is sort of the canonical URL for the project. So you'll see you have app Radical Network seeds, the seed node, and then the project ID, the project URL. And then the second one is the same thing, but it also has my peer ID added to it, which means that this second URL is kind of my own source tree of this project, whereas the top one is sort of the canonical one. And if you are the maintainer of the project and you're the sole maintainer, then these two will point to the same thing. But if you're not, the second one will, the first one will probably not be showed actually. So let's check this out on the app. So I'm just going to copy this and switch screens. Give me a second. Okay. All right. So here I am in the web interface, and you'll see a couple of things you can recognize. You'll see the project ID here, name of the project, the README that we updated. You'll see that this data is fetched directly from pine.radical.garden. We can see the commits, initial and second commit. We'll see our branch. And then here there's something that is pretty unique to Radical. It's called the peer selector. And it's a little bit equivalent to on GitHub the forks. So here you can see the only peer is myself with my peer ID here, and it's telling me I'm a delegate. Delegate means sort of a trustee of the project that can sign on behalf of the project. And I'm a delegate because I created the project, so I'm automatically a delegate as a creator, but you can add more delegates to a project later. Now, if I click on this, I'm going to see the same thing, but actually in terms of the commit and everything, but I will have this peer selected as the current peer. And here I will also see that I'm browsing a specific view of the project or a specific source tree. So when you have people you're collaborating with, you will have them show up in here, and you'll be able to browse their individual forks, basically. One other thing to keep note of is there's two ways to clone a project. There's the kind of standard Git way, which you can just do git clone and this URL, and you'll get a clone of the source code. But you will not get a clone of the project identity because the project identity is not part of the source code. It's part of Git, but it's not part of the sort of source code, like working copy source code. If you want to actually clone it via Radical and get like all of the metadata, then you would do rad clone. And we can actually try this out. I'm going to copy this and go back to the terminal. And here we go. So let's say I was in a different folder here. So here I have the one I created, but let's create a clone folder and go in here, and then paste this command, rad clone, I don't know. And these URLs basically incorporate the seeds and the project IDs, essentially the project ID without the rad kit prefix. And so if I enter this, you'll see basically something very similar to when we did a rad init. It's going to, well, first it's going to sync everything, but then it's going to initialize a checkout. It's going to ask me again if I want to configure my sign-in key on this checkout, and then it's done. And then I can go into Web3Con here, and we'll see that it's just the same thing as we had previously. So yeah, that's pretty much it for at least the kind of push and clone flow. If you want to kind of explore the other commands, you can just type rad and look at the other stuff we have. So for example, we can list our projects with radls, so we can see this one project that we created. We can also look at our tracking graph, which I'm not going to explain in depth right now, but what it is basically is the peers that you know about around a certain project. So here, I only know about myself. So I see myself here. I see that it's me and that I'm a delegate of the project, and I see my my latest commit. You can manage these with track and untrack, but again, not going to go super in depth. Yeah, and then as Abby said, we have some cool features around ENS also, which so the ENS stuff, I also I'm not ready to show it right now because I would have to get my ledger out and all that sort of stuff. But essentially, yeah, it lets you associate an ENS name with your local radical identity. So you can see if we go on rad self and we actually do rad inspect on this URN, which is our self, you can see the payload here, which is a JSON document, and right now the only metadata really is that is my name, but this is extensible, so you can add other sections like this. So this is kind of like a JSON schema type thing, which tells you, okay, this section is kind of the canonical person v1 payload, which just has a name in it. And this can be extended with other things, and that's how we support ENS. It's by extending this with your ENS name, and then of course these updates to the identity are all signed with your key, so they're secure. All right, that's it for today. Thanks for listening.
This talk is sponsored by IPFS and Filecoin. This talk is sponsored by IPFS and Filecoin. IPFS and the Filecoin Foundation are fully distributed open source organizations that aim to help radically improve the internet and drive breakthroughs in computing, which can help move humanity forward. Learn more at filecoin.io and ipfs.io.
Hello everyone, my name's Kyron and I'm going to be talking about diversity and accessibility within Web3 and why it's important. I'm excited to be here at Web3Con talking about something that's quite close to my heart. I'm currently building a project called MetaDiverse, where we highlight diversity within Web3 and advocate for diversity and inclusion within Web3. So yeah, let's go to the next slide. So a short introduction. Web3 is a massive opportunity right now to build an internet using our imagination. We can build new worlds, we can build new tools, we can build new ways of interacting with the blockchain and internet. And an important part of that ideology is, challenging monopolies. As we've seen within Web 2, most of the internet is stored on servers by a few companies. And, obviously the Web 3 technology in terms of decentralization can challenge that. And building trust, obviously within Web3, we have the opportunity to see where transactions are coming from on the public ledger as it's named. And this allows for us to see how individuals or organizations interact with the blockchain. Decentralization is very important within DAOs at the moment. It's allowing people to gain jobs, to work in a different way. But also in terms of decentralization, people were able to stake, people were able to contribute to networks, people were able to run nodes, which basically is something you wouldn't have seen within traditional finance. People were able to contribute in a totally different way. And a massive thing as well as the encryption technology. In Web 2 at the moment, I think we just kind of accept that there will be data leaks, private information will be on the public internet. And what Web3 technology allows us to do is solve some of those challenges in terms of how data is stored and just make things a bit safer for individuals who interact with the technology. So a big question for me is, how do we create this new internet? How do we create this Web3 while encouraging diversity and being accessible to as many people as possible? And I want to put that question to those who are listening as well. So something I want to highlight when I talk about diversity and accessibility is the idea that it's about inclusivity for all. So I just want to define diversity and accessibility first, just to give a simple way of looking at both. But when I say diversity, I'm talking about involving people from a wide range of backgrounds. And when I talk about accessibility, I'm talking about removing barriers for people with different needs. So an important word I want us to think about as well is equity. Essentially, equity is about making sure everyone is treated fairly according to their needs. And I think that's important because when I mention accessibility, removing a barrier might mean putting up a ramp for someone at an event so that people who are on wheelchairs can access that event. That might take more time than, creating something more accessible for someone else. But it's still important to do that, to do something for that person's particular needs to make sure the event is accessible. So why? Why is this important? Why is accessibility and diversity important within Web3? So if you were looking at it from a purely selfish standpoint, as we age, accessibility becomes more important because we lose the ability to see lower contrast things. Also, our cognitive ability can become more impaired. So by having more accessible design, obviously it helps us as we grow, and also obviously there's many older people that exist within the world as well, and also younger people as well. So clearer design and layout benefits a wide range of people. So clearer design make it easier for someone with issues with executive function, someone with ADHD, for an example, but also for somebody who may be stressed on a particular day or maybe in a rush. These things obviously help a wide range of people, not just those that may have accessibility needs, but just generally help people to to have a better experience with your web app or with your application or website. So communities that encourage diversity are happier, which is massive. People feel more included, people feel like they can express themselves more, and just generally people feel more comfortable when they know that they're, people aren't going to be discriminating, or, people are just encouraged to be themselves, essentially. So a quote I want to touch on by Sonali De Silva is, "Judgment can afford to be lazy. Inclusion is a skill that takes courage, empathy, and practice." The reason this quote is so important to me is because diversity and accessibility are things that we need to be active in doing. It takes courage in the sense that we have to be open to the fact that we may have much to learn in those areas. We also have to be open to the fact that in the past we may not have been, thinking as much about accessible design, and we may not have been creating environments that would have encouraged diversity as much as we may have liked to. Empathy in the sense that we listen to different perspectives, we encourage different perspectives, we welcome them. And practice, of course, the most important thing is putting these ideas into practice, and as I mentioned before, actively, trying to act in a way which encourages accessibility and encourages diversity. So we're early right now. What are the costs of being early? So with this technology, sometimes we can like that we're early because maybe we're more tech focused, but this can be challenging for new users. Or for users who have accessibility needs and so forth. So I've seen before just a plain white page with minimal text, something that you probably would have seen in the 1990s, and just like a button that you interact with. Obviously, for somebody who might be more tech aware, they're willing to take that risk. But for new users or people with accessibility needs, they may look at that and that might scream scam. So on the opposite end of the spectrum, you might have a website or application that uses a lot of complicated jargon, doesn't really break things down simply. So obviously for new users, this can be very challenging. It can be off-putting. And I think it's important we think about how we can explain things in an easier to read way or a simpler way, just to make what we're doing more accessible. And lastly, just communities discouraging to newbies, telling people to find information themselves, expressing that complicated ideas behind Web3 are very easy to understand, or just being generally rude or discouraging to questions. I mean, one community I saw, they were just being very negative towards community members and explaining their own thoughts were very easy to understand. Now, I know somebody who's been investing in crypto for 4 to 5 years. They invested in own thoughts themselves, but they don't fully understand how the technology works. So it's quite almost patronizing to say to a new member of the community, or quite rude, should I say to a new member of the community that this is very easy to understand when it's very difficult for people to understand. Okay, so what can we do when it comes to accessibility? So I think the most important thing is using elements that contrast well. So this just opens up your website to a large group of people who may have issues with sight, who may be a bit older. I think it's very important to think about that when we're designing within Web3. Also, responsive websites where all elements work. When the website is made bigger, this is massive. Someone wants to zoom in and the website isn't working properly. Obviously, that can be a barrier to them. So making sure that the website still works regardless of the sizing of it. Alternative text for images and media. This is important for people who may be blind. If they're listening to the website, having a description, having a description of an image or a description of the media that's being played can help them to be able to access things a lot easier. And using labels and markup language to structure your code. So this helps somebody who may, have struggled with their sight, in the sense that they can hear which areas of the website are, the article, the main body, which area is the bit to interact with, and just keeping that structure throughout your code, throughout your website on the different pages. And I've included a link to a resource, w3.org /WAI. It just goes through how to make your websites more accessible, and it applies to Web3 as well as it does to Web2. Okay, so if there's one thing I'd like you to take away from you today, it's this website called Cards for Humanity. basically what this website allows you to do is to look at different users. It's randomized and their needs. And it's an interactive tool, so it's simple to use. And each card gives you a random user with 2 traits. And you can flip over the cards. It goes to a bit more detail about what their needs would be. But essentially by using this, you can create user stories with it. You can use it when you're designing, when you're building your web apps or your Web3 application, should I say. And it just allows you to think from different perspectives. It allows you to be a bit more open-minded as well, and just hopefully create an application that is a bit more accessible than it could have been before you interacted with this website. So I think it's a very important tool. And yeah, like I said, if there's one thing that you can take away with you today, it's this website. Okay, so what can we do on a diversity front? I think offer mentorship to people from diverse backgrounds is important. Getting people from diverse backgrounds on panels, making sure they're represented essentially, so that other people, when they come into your communities, maybe they haven't got as much access to people who would be tech aware, crypto aware, and having that representation within your communities is going to help them, of course. Acknowledge that implicit and bias exists. I know this is one that people kind of shy away from sometimes because it is quite a difficult topic, but essentially I think I like to acknowledge it in myself. We've grown up in cultures, we've grown up in societies where sometimes we've had particular messages shared with us, and sometimes we internalize those things. So I think it's important that we accept that it exists, and then from that place we can move forward to then challenge it and figure out ways to not allow it to affect us or affect our cultures or affect our organizations in the same way. Importantly, accepting people from non-traditional backgrounds. Somebody might might be neurodivergent. They might just not do well within a university environment, but they might have a portfolio. They might have examples of their work. They might have done a boot camp. They might have done self-learning. And I think allowing those people to access the opportunities that exist within Web3 is very important because, that is obviously a barrier, accessibility barrier, and oftentimes a diversity barrier as well, because somebody might be poorer, they just might not have been able to pay for university, or they might have to go straight into work. So having that opportunity for people is massive. And lastly, just encouraging different perspectives. It helps create an inclusive culture where ideas and questions are welcomed. And I think that's important. I think diversity, as much as it's about getting people from diverse backgrounds and obviously different socioeconomic backgrounds involved, getting people with different agendas involved, I think it's also important to encourage a culture where people feel heard, where people feel valued, where questions can be asked, ideas can be put forward. I think that's very important as well. So some just issues I've seen, language only addressing men or people assuming everyone is a man within Web3. Obviously, I don't want to go too much detail on this, but when you do that, obviously you're excluding the other people that engage with Web3. Not safe for work gifts and new content being shared openly and chats or in communities. I think this is important. You don't know where someone is, you don't know their cultural background, whether they feel comfortable with that sort of information being shared, those pictures being shared. And obviously a lot of the time it's women being shared in those gifts and new content. Some women may be comfortable with that, but some women won't. So I think it's important just to think about that as well in terms of our communities. And just some language that's creeped a little bit into Web3 at the moment. People selling coins are being called a particular sort of word at the moment. And I think encouraging or challenging that sort of behavior, should I say, it is very important. People from all backgrounds sell their coins. That's crypto, unfortunately. That's investing, unfortunately. If you look into the psychology of trading, it's about people being fearful and obviously happy at certain points. And I think generally people follow that sort of trend. So yeah, I think it's important that we challenge that language. Okay, so I'm going to leave you with some stats lastly before I go to the thank you slide. So gender, age, and geographical diverse teams make better decisions 85% of the time. I think that's massive benefit. 70% more likely to capture a new market. Obviously, we're in crypto, which is, I would like to think, is being seen as a new market, or even if there's new markets within this market, obviously having a more diverse team is going to benefit you massively. 35% more likely to outperform competition, which is obviously massive as well. On the accessibility front, the world's population have 15% of the world's population have some sort of disability. Obviously, that's quite a lot, and I think making sure that we're accessible is allowing those people to obviously have access or have more access to what we're doing. 86% of websites fail to be accessible because of low contrast. This is massive. It's a very simple thing that can be done on websites, on Web3 applications to make it accessible. So I think this is something that's very important. And lastly, companies without accessible sites lose 6.9 billion to competitors that do have accessible sites. So what I would say is, like, I was doing the reading on this, and people who go to an accessible site, they will generally come back because they know that they're catered to within that site. So by thinking about accessibility, you're opening up your applications to loads of people that are going to want to come back if they feel like they're catered to in that sense. So I just think it's very important to do that. So yes, thank you for listening to me today. I talk about diversity and accessibility within Web3. My name's Kyron. If you want to be in touch with me, I'm on Twitter at Kyron. I'm currently building MetaDiverse Web3 at the moment, and we're currently focused on collating material. So we're making lists on Twitter of educational resources, diverse NFTs, accessible projects. So check that out. And the website is linked there as well, www.metadiverse.com. So yes, thank you so much.
and API access, so builders can build their projects easier. Just connecting to us, you don't have to worry about running a node. And I'm here to talk to you about NFTs. This is a little bit more developer focused, but what I hope to cover here is a little bit of background and use cases with NFTs. Describe some common project concerns if you're building NFT projects. We'll use a tool called Replit and Infire's IPFS API to deploy and mint an NFT, do a bit of live coding. And finally, we'll introduce the Consensus NFT API, something that's up and coming that's pretty exciting. All right, so NFTs. Why are we talking about NFTs? As people in this room probably know, they're pretty popular right now. Whether you know they're headline news with Beeple and like $100 million sales. The marketplaces like OpenSea are starting to get more into the public consciousness. Traditional auction houses like Christie's is auctioning off NFTs. So they're really starting to enter, I think, grow outside of just the Web3 circle. So what is an NFT? If it hasn't been covered before, I'll try to define it here, right? So fungible is something where you have a set of like objects or a set of like items, and you can exchange them for like value. So coins, fiat currency, ETH, Bitcoin, those are all fungible tokens. Non-fungible tokens then implies that you cannot trade them for like value, right? So there's a uniqueness, there's a rarity among the NFTs, amongst the tokens, where I can't just give you my token, you can give me your token, and it's a fair exchange of value. Diving even lower at the developer level, what defines an NFT is simply conformance to one of these two standards that I have on the screen here. ERC 721 or ERC 1155, right? If you implement those interfaces, congratulations, you're an NFT. Simplifying it even further down, the way that I define an NFT is basically metadata that's saved on chain, right, with this token URI. The token URI points to metadata, which defines the NFT, and there's an address that owns that NFT, right? This is really all that we're talking about today. All right, so allow me to get on my soapbox for just a second. While the dominant use case of NFTs is digital collectibles and digital art right now, I wanted to point out some use cases that kind of make the case that NFTs are so much more than just digital collectibles, right? ENS domains, as an example, they conform to the 721 interface, therefore, they're an NFT. They can be transferred and traded just like any other NFT. Other use cases are like real-world deeds. There are projects out there that are trying to take real estate deeds and sort of real-world property and tokenize them on the blockchain using NFTs. And finally, the one that I think is a little bit more interesting and maybe a little bit esoteric is this idea of negative value assets. Like there's an idea that you can take an NFT and represent, like, say, debt paper with it or loans, in which case it behaves like an NFT, right? You can't trade it like for like. But the holder of that NFT could have all of the rights and privileges associated, just like in traditional finance, holding debt paper. All right, now that I said all that, this talk is going to be about digital art. So if you're doing a digital art or a digital collectible project, these are the kinds of concerns that might be floating through your head as you're putting your project together, right? What contract am I going to use? Is it 721? Is it 1155? Do I need to use extensions? Like, am I going to have royalties on this? Sealed metadata. There's a ton of extensions that you can also implement around NFTs. And if you're rolling this yourself, do you need to be an expert at security, at auditing your contract, or do you need to hire, something like Consensus Diligence to do an audit on your contract? How comfortable do you feel with real-world value flowing through the contract you just wrote? Another aspect is around the metadata. How do you generate and store all the metadata that is attached to your NFT? I'll dive a little bit further into that in just a few moments. And finally, when you're minting or dropping the NFT, like, what are the mechanics around that? How are you going to do it? Are you going to script it, or are you going to create software to script it? Are you going to do it by hand? Are you going to use a platform like OpenSea or a marketplace where you can just do it through the interface? All right, so let's talk about storage. For storing the metadata and storing the assets, there's basically three methods you could use, right? You could do centralized storage, which is your traditional web hosting. You're going to get a DigitalOcean droplet or a Heroku and host images from a web server, right? Extremely easy, flexible, low cost. Problem is that it happens to be censorship prone. You know, what if your hosting provider isn't welcome in certain geographies? What happens if somebody doesn't pay the bill? What happens when your web server goes offline? So generally not recommended. On-chain storage is an interesting idea. So that token URI that I was talking about can be any URI, including a data URI. So you can encode all of your metadata and save it on-chain. This is great because it's simple, not a lot of moving parts, but it's expensive because you're basically taking all of this metadata and using the chain to store it, right? It's something that you'll have to weigh. The best option, in my opinion, is decentralized storage, something like IPFS, right? It keeps your on-chain storage down so that you're only saving a URL. It's decentralized and has content ID, so you know it's immutable and it's not going to change. And while there's some additional moving parts, like you have to find an IPFS provider or host a node yourself, I think it's worth the additional complexity. All right, so let's mint some NFTs. This is the general thing we're going to be stepping through today. We'll have to collect our assets and store them on IPFS. We'll generate the metadata, store that on IPFS. We'll use Replit to deploy a contract, to mint an NFT, and then we'll make millions of dollars. So let me talk about Replit for just a second. So Replit is a company that makes these sort of online coding environments. It's a really great and easy way to set up, right? It's free, zero setup, zero config, browser-based platform. All you have to have is an internet connection and a browser, and you have an IDE that you can collaborate and share with, right? They launched a Solidity template 4 months ago, which is the basis of the Replit that I'm going to use today. And this is what it's going to basically look like. We'll start from that general Solidity template. I've added some tooling for IPFS and some integration with Infura so that if you wanted to play with it, all of these tools that I'm doing today are out of the box. The basic work around this is you connect the REPL with your MetaMask wallet. You modify the contract Solidity file with any custom logic, anything you want to do there. Manage the assets on Infura's IPFS API, and then deploy and mint. It's pretty easy. And then if you're working on a team, you can share the URL of your REPL, and you can collaborate all in real time. All right, so let's go to demo time. This is the usual warning of live coding demos. All right, so let me just make this bigger. All right, so if you can see on the screen, this is what Replit looks like. You can see there's a code editor here on the left. There on the right, we have a UI. This is where you would connect your wallet. I've already connected my MetaMask wallet, so if not, you would see a connect wallet here. Something to deploy, all of the contracts, all of the NFTs, and then once you've deployed an NFT, you can just call functions within this UI. On the bottom panel here, there's a shell that we can use to interact with the environment, and this is how we'll be managing the IPFS assets. Now, before we get too deep into the live coding, we have to do a little bit of setup. So what you want to do first is either sign up or log into your Infura account. By the way, everything that we're doing today qualifies under the Infura free tier, including all of this IPFS work. So if you wanted to play around with it, there's no charge for any of the stuff that I'm doing up here. So once you log in, you'll want to create a project. Up here, select IPFS, name the project. Since I already have projects created, I'm just going to use one of my pre-baked projects. You'll be dumped to a settings page here where you'll see the project ID and secret. So you just copy these project IDs and secrets, come back to the secrets manager in your REPL. Pretty cool, right? Secrets management. And then you'll want to create these two secrets, right? Project under ID, project under secret. These case and words matter here. Input your project ID and project secret, and then you're ready to go. By the way, in this README, all of this stuff that I'm doing is here in this README in case you want to look at it later. All right, so back to live coding. This contract soul is what gets compiled and what will get deployed. Right, anything defined here, you can choose to deploy. So I'm going to start with this NFT 721 contract. And since I used a bunch of sort of like badly made memes for this presentation, we're just going to use that as our NFT source. So we'll name this bad meme token. You can give it an NFT name and a symbol, which is part of the spec. So bad meme token. And the symbol, let's just say it's BM. Right. So now you see it compiles, it saves and compiles automatically. I didn't have to hit save. And you see the bad meme token listed here in the dropdown. All right, I'm going to try to deploy this. All right. Great. Live coding. Give me just a second. Nobody look at my password. By the way, if you don't use 1Password, you should. It's a great tool. That is not my password. All right. Let's try this again. And let's see if I can get this reworked. Give it a second to boot up. All right. One more time. Confirm. All right. So while that's deploying and we'll wait for that transaction to get confirmed, I'm going to drop in over here to the assets. So let's look at the IPFS part. So I've created in this folder assets. These are all my images and all the metadata that describes those images. The metadata adheres to the OpenSea metadata standards. So if I wanted to hawk this stuff on OpenSea, it's completely compatible. OpenSea should be able to read it and make it freely tradable, right? Take a look at that standard if you're diving into OpenSea type projects. So the IPFS, npm run IPFS -- directory is assets, images, and this is pattern match, so you could just use a glob, everything that ends in JPEG. I think that looks good. I need quotes here. All right, now while that's running, it's going through this directory and uploading it to IPFS. So you can see all of my images that I have in this directory now are now stored in IPFS. You'll want to pay attention to this HTTP link. If I were to click it, it opens the image in IPFS, getting served out of Infura's gateway. So now that we have all of the image URLs, we have to make all the metadata. I cheated a bit and I did all this beforehand, so I have all the metadata in the JSON files. So pretend that I copied and pasted all of these URLs into this metadata JSON. Or I was clever and I made some script to do it. Now we need to sync this metadata JSON to IPFS. Easy enough. Oops. I have to change it to the JSON directory. Live coding. All right. So now all of our JSON files are now stored on IPFS, and I can start minting tokens. So while I was talking, you can see that bad meme token has now deployed onto the Goerli network. I can now run transactions against this contract. So I'll come over here. Let me just get this down a little bit. Here's our mint function. So this is basically how you mint NFTs. I'm going to come up here and just grab my own address. as a recipient, I am going to grab the token URL of where our metadata JSON is. I am going to run that transaction. Confirm, and it's on our way. That easy. We have now accomplished NFT. Thank you, thank you, thank you. Yeah, thank you.
It's for Q&A.
I have one more thing before we kick into Q&A. Let me just go. So we did this at a very low level, right? We're talking about contracts. We're talking about IPFS deployment. We're talking about like deploying in transactions. Well, let's say you don't got time for none of that. Well, Consensus is going to be releasing a Consensus NFT from our NFT group. And what it will be is a full cycle SaaS platform powered by APIs, SDKs, CLI tools. It's going to come out of the box with a white label market storefront that can support primary drops and secondary trading. Normie buyers can redeem NFTs through email. It's got Stripe integration so you can pay in fiat. It's basically an out-of-the-box solution for NFT projects if you're interested. This QR code goes to this presentation, so all of the links, all of the tools, like everything that you need, you'll have access to. It's a public presentation. Thank you.
Thank you.
This talk is sponsored by Decentology. Decentology is the innovative company behind. This talk is sponsored by This talk is sponsored by Decentology. Decentology is the innovative company behind the Hyperverse, the open, composable smart contracts marketplace that makes it easy for developers to build Web3 apps without writing a single line of smart contract code. Learn more at decentology.com.
Hi there, I'm very excited to be here as part of Web3Con, and today we're going to talk about security and vulnerabilities in Web3. So my name is Harry Papakarisiou, and I'm a developer advocate for Chainlink Labs, and there are my socials there if you want to reach me. I'm also a member of Developer DAO and very excited to be here today. So before we begin, I just want you to imagine a scenario. So imagine that you're head of cybersecurity at a big bank, right? It could be Bank of America, HSBC, or some other big well-known bank. And imagine that you're in charge of preventing hacks and cyber attacks for your bank, right? Imagine that everyone can read all of your system's code, right? Imagine all the code is open for anyone to see. And on top of that, imagine that the transactions that take place in your bank are also all completely open and public for anyone to see. Does that make you a little bit nervous? And on top of that, imagine that in the event of an attack, if all the funds are stolen or some funds are stolen or taken, imagine that those transactions are irreversible, right? Imagine that there's no other bank or institution or financial company to stop or reverse the transactions from occurring. How would this make you feel? Does it make you feel even more nervous, right? This sounds like a fairly nerve-wracking scenario, doesn't it? This is exactly the scenario that Web3 developers face every day when they build their smart contracts, right? Visible code, transparency, immutability, all great features of blockchain technology that unlock endless possibilities. However, they also give malicious actors a much easier setup for attacks to occur over their traditional counterparts. So it's for these exact reasons that we as Web3 developers need to remain vigilant when building secure Web3 systems. So here's the agenda that we're going to go over today. We're going to talk about smart contract exploits and vulnerabilities. Then we're going to look at Oracle exploits, and then we're going to talk about randomness and cross-chain exploits. And then we're going to finish off by talking a little bit about front-end phishing attacks and close off by discussing Web3 security and best practices. So let's start with smart contract exploits and vulnerabilities. So smart contract exploits can generally be split into two scenarios: bugs in the underlying blockchain protocol, or bugs or vulnerabilities in smart contract code. And while we need to absolutely remain vigilant on both scenarios, we're going to focus on the second one today because it's generally the more popular one. The underlying protocols are generally a bit more mature, especially if you're using things like Ethereum and some of these chains that have been around for a while. So in terms of a life cycle, smart contracts can be kind of thought of as more like hardware than software, right? So with software, if there's an issue, you can release a patch, send it out, everyone's program gets fixed, and then the issue's no longer there. You can't really do it with a smart contract unless it's built into the smart contract, right? Which we'll discuss later. Once a contract is deployed, it cannot be altered or modified, right? So you can think of it as like hardware, right? Where once it's out in the world, that's it. Can't be changed or fixed unless it's kind of sent back. So in terms of what is a smart contract exploit, right? There's a bit of text on there that you can read. However, I guess an easy way to summarize it is basically it means someone figures out a way to interact with a smart contract where they can steal funds or gain some kind of advantage while other people get screwed by that action, right? So that's kind of what it is in a nutshell. And they don't hack the smart contract. The smart contract can't be changed, like I said. They just exploit the logic in it, right? They find loopholes in the logic where they can unfairly take funds or do things at the detriment of other users. So here are some of the most popular and widely known smart contract exploits that exist today. We have things like reentrancy attacks, race conditions, front running, denial of service attacks, overflow, underflow errors, delegate call, TX origin and unexpected ether calls, which are kind of EVM specific things, as well as timestamp manipulation. So I won't go into detail on each one of these because it will take up a whole talk in itself, but I urge you to do research on these if you're building Web3 systems that control user funds especially, right? So essentially they take advantage of some of the nuances of programs or smart contracts running on blockchains, and some of these can get quite tricky. So, while many of these have been around for a few years now and are kind of mature, we still get exploits happening using some of these smart contract exploits. So please remain vigilant, have an awareness of some of these smart contract exploits when you're building your Web3 systems. Now, if you want some real hands-on experience with some of these exploits, I can highly recommend this Ethernaut game. Basically, it's a Web3 Solidity-based war game that takes place in the EVM, where each level is basically a smart contract that you need to hack. And by hacking the smart contract, you learn about the vulnerability and how to exploit it and things like that. So it's really cool for learning about smart contract exploits. The game's 100% open source as well if you want to contribute your own levels to it as well. So yeah, highly recommend that if you're interested in that. You can check it out at ethernaut.openzeppelin.com. Okay, let's talk about Oracle exploits. So Oracle exploits can be split generally into two categories. The first one that we see is what are called flash loan attacks. And then the second one that we see is basically price Oracle attacks or Oracle attacks due to low quality or incorrect data provided by an Oracle or oracles. So let's talk about flash loans first. So flash loan is a new special type of loan that's only possible in crypto. You can't do this with the traditional finance world. And basically the way it works is you can borrow a certain amount. Usually it's a large amount, say $1 million, $10 million, whatever. And you could borrow that money in crypto and do what you want with it as long as you pay that loan back within the same block, right? So the block that's generated as part of the blockchain. So within one block, you need to borrow the funds, do whatever you want to do with them, whether it's an arbitrage, a leverage trade or whatever, and then pay back the loan. So all those transactions need to take place within the block. If you don't pay back the flash loan within that block, the flash loan transaction is deemed invalid and cancelled and it never takes place. So what this does is it creates unique opportunities for things like arbitrage, collateral swapping, and the creation of leverage positions, right? But it also creates certain risks because if bad Oracle solutions are used by the underlying protocols that people use, whoever is taking out a flash loan of a large sum of money can do some nasty things with it and essentially steal from other people. So the problem occurs basically if the flash loan is used together with a protocol that uses a single data source for its price data. So if it gets its price data from one data source, one exchange or something like that. So the flash loan can be very large, right? So millions of dollars worth. And basically what you can do with that millions of dollars in crypto is you can easily change the price of an asset on that single data source, on that single exchange that's being used for price data. And then that then completely changes the collateral debt ratio on the DeFi protocol that's being exploited, right? And basically it allows the exploiter to then essentially take funds from the protocol from it before the prices are brought back in line by arbitrage bots and things like that. So let's talk about price Oracle attacks now. So these are generally due to bad, low quality or incorrect data being fed into these Web3 systems by oracles, right? So bad data in, bad data out, right? Or in many cases, the protocols can go underwater. So using a single oracle, single data source is definitely a big no-no, as we just explained. Using a DEX or AMM reserved for price data can often lead to exploits as well. And using what's called a time-weighted average price for aggregating price data is generally not recommended because using time-weighted average price is a lagging indicator which isn't really reflective of what's happening at the current time during periods of high volatility. So what can you do to kind of mitigate these things? The best thing you can do is to use a decentralized Oracle network for sourcing your price data. such as Chainlink here. So use multiple data sources, multiple oracles, use volume-weighted average price aggregation method, right? So do all of these things and you're basically protected against some of these attacks that I described earlier. It's an industry standard solution that's been implemented across the industry and trusted by some of the biggest players in the industry to the tune of billions of dollars, right? So very easy solution there. So let's talk a bit about randomness exploits now. So randomness is becoming more and more popular requirement for Web3 systems, right? From NFT mints to blockchain gaming, people want randomness as part of these systems, just like randomness exists in the traditional web world and gaming world and things like that. But randomness on a blockchain is not an easy thing to achieve because blockchains are deterministic by nature, right? So you can't actually have a true source of randomness directly on a blockchain. So what some people do is they reach out to an oracle and say, hey, get me a random number or get me a source of randomness. And that's fine, but the problem is, how do you know the random number that you get back is actually random and it's not just some number that's been predetermined by the oracle or system that's feeding that random number? They've kind of put in a specific value because they know they're going to be able to exploit your system using when that value is used as the random number. So it's kind of a bit of a tricky situation. Another thing that some people do is they use on-chain data for their source of randomness. And this is even worse because, as I explained earlier, blockchains are deterministic in nature, right? They're not, you can't get true source of randomness. So when you use things like block hashes, block timestamps, nonces, block difficulty and things like that, even if you hash them together and things, all of that info is deterministic and people can use that to their advantage to exploit your protocol or system or whatever it is you're doing, right? Or they, in the case of a game or something, they can constantly re-roll with cancelled transactions until they get the random number that they like, right? So using an on-chain random number generator in this way gives users and or miners influence over the random number, which is not good. So solution, use a provably random number generator. Provably fair will always beat probably fair 100% of the time, I guarantee you that. So use a provably random number generator such as Chainlink VRF, right? So what this is it's a system that, an oracle system that basically reaches out to an oracle to get a source of randomness. However, when the random number is returned, there's also a proof that's returned that proves that the number is actually random and it was created based on the input seed that was given and not just some random number that was given back to influence the NFT mint or game or contract or whatever it is, right? It's a provably random number where we can prove the number it was derived based off of the initial seed that was given on the original request for randomness. Cool, so let's talk about cross-chain exploits now. So cross-chain in general is a very new and bleeding edge part of crypto. So crypto in itself is on the bleeding edge of tech today, but cross-chain is like the bleeding edge of the bleeding edge, right? So it's very new, very tricky, very complicated, very hard. Right? So because it's kind of very tricky and hard, if these cross-chain protocols aren't designed right and aren't designed with security as the main focus, it could often lead to exploits and a loss of user funds, right? So a cross-chain exploit is basically when a malicious actor takes advantage of the cross-chain protocol to essentially steal funds, right? So by minting or taking funds minted on one chain, and they generally leave the collateral on the other chain underwater, right? So just to go through a scenario, let's say you have chain A is Ethereum, chain B is, chain B. And let's say on Ethereum you have 10 ETH and you use a cross-chain protocol to mint wrapped ETH on chain B. So you get 10 wrapped ETH on chain B, but then a malicious actor comes along and all of a sudden they figure out a way to mint 100 wrapped ETH on chain B out of thin air, and they take it and then they send that back through the cross-chain bridge to Ethereum, and they then turn that back into normal Ethereum and they steal 100 Ethereum that they never actually owned, right? So that's an example of how a cross-chain exploit can work. So these cross-chain attacks are very possible, very real, and they have happened. There's been a couple large instances in the last year where a bit large number of funds were exploited and stolen because of bugs in the cross-chain protocols. Right. So in fact, one of the biggest crypto hacks of all time happened recently, and it was a cross-chain exploit that caused it. Right. So someone literally took 320 million crypto because they were able to exploit the cross-chain protocol used between two blockchains. So it's kind of hard to talk about solutions for cross-chain because it's something so new and untested in the world of Web3, and it's not very mature. So all I can really say is, as a user, remain vigilant, and be careful about how much funds you have locked up in these cross-chain protocols, right? Because they're very new and they're very tricky. If you're a developer that's building a protocol that needs cross-chain functionality, we as in Chainlink Labs are building our version of a cross-chain protocol. It's called CCIP. It's coming out later this year, and it's been years in the making, and we've got some of the best researchers on the planet focusing on this cross-chain issue and coming up with the best solution for it. And it's got a number of advanced features such as anti-fraud networks and things like that to kind of mitigate exploits from happening. So keep an eye out for that one. So let's talk about front-end phishing attacks. These are kind of some of the most heartbreaking exploits, I think, and not just for Web3, but across the whole internet. So basically a front-end phishing attack is when an exploiter tricks users into thinking they're using a specific website or app or protocol, when in reality it's not. It's one that looks like it, but it's actually hooked up to back-end protocols or smart contracts or whatever belonging to malicious actors, right? And they can steal funds based on that. So it could be an email from, say, Coinbase that says click here to fix your account, and it actually goes to another website that isn't Coinbase but looks like Coinbase. Or sometimes they actually gain access to the actual registered URL. So you think you're doing stuff on OpenSea because you're at the OpenSea website, but it's actually interacting with smart contracts that are not OpenSea smart contracts, right? So this usually results in funds being stolen. So these can be tricky to spot because often the website or front end looks exactly like the original one. So in terms of solutions, once again, there's not too much I can say other than hopefully as a be vigilant, and aware of which smart contracts you're signing transactions for. Keep an eye out on Web3 socials. So whether you're using OpenSea or Coinbase or whatever it is, keep an eye out on their socials. If there's a front-end phishing attack, they'll communicate it straight away to everyone. And also when you're using online wallets and stuff, don't sign any transactions with your wallet that you're not 100% sure of what it's doing. If you think it looks different to what the transaction normally looks like or anything like that, don't sign it. Ask around in Discord, forums, things like that, and get more info. But hopefully as the Web3 space matures, we come up with a better way to identify and certify some of these on-chain contracts that people use, so that in the event of a front-end phishing attack or something like that, we can kind of know and say, hey, no, this website's not sending the transactions to the OpenSea website, it's sending them somewhere else, right? So now that we've gone through some of the more common security considerations and exploits in Web3. However, be mindful that it's not a complete list. We don't know what we don't know. We don't know what will be found tomorrow, a year from now, 10 years from now, right? We don't know what we don't know. So we need to try and remain vigilant and have an open mind. But now that we've delved into the past a bit, let's look at the future and talk about some of the things you can do to avoid situations like this from happening. Or if they do happen, some of the ways in which you can mitigate them. So the first thing you should do is test your smart contracts. Test. Test every line if you can. Test all the important scenarios. They're great. Tests are great for catching careless mistakes and for edge cases, right? Can't stress that enough. Test your smart contracts. There are some great testing tools that you should use with your tests as well, such as Sliver. Coverage reports are great because they will tell you how much of your code has been tested by your tests, and you can see if your tests are comprehensive enough, or if there are certain functions or areas of your code in your Web3 system that needs more focus, right? So highly recommend using coverage if you're writing stuff in Solidity. So we all know smart contracts are immutable. So what can you do if you find a bug or issue with your smart contract, right? And it's already deployed on Mainnet. So sometimes when a bug or vulnerability is found, devs just literally just ship a new version and say to everyone, hey everyone, stop using this one, that's the old one that's broken, use this new one instead, right? And that's fine. It maintains immutability, it's easy to audit. The only consideration is sometimes it may require some data migration. Another solution that some devs take in mind, which is quite popular, is using upgradable contracts, right? So basically the contracts are set up in a way to allow for new versions to be deployed and used without having to socialize the fact that you've had to make changes. And a lot of them make use of what's called the proxy design pattern, where you have what's called a proxy contract, which all the users always interact with, but that proxy contract does not have any logic in it, and it basically just forwards requests and function calls to an underlying implementation contract. And that's the one that has the code, that's the one that has the logic in it. And if there's an issue with that logic, you can easily swap the implementation contract out with a new one that has the issue fixed. The proxy contract still will then interact with a new one. The users still interact with the proxy contract, and there's been no change in terms of what the users interact with. Just one point with this one is there are some centralization considerations, because who has access to swap out the underlying logic? Is it one person? Is it many people? Is it multi-sig, etc.? One way to potentially stop carnage from occurring when bad things happen in your Web3 protocol system is to have what's called a kill switch, right? So if you have an emergency kill switch feature, you can make sure basically that you just halt your protocol from operating, right? It's basically just a function call that basically just stops anything from happening in the protocol. It's great for preventing widespread issues. However, once again, there are some centralization considerations, right? If there's just one user that has access, or one admin person that has access to your kill switch feature, then you don't really have a decentralized system anymore, and it kind of undermines the whole Web3 ethos a little bit. So just be aware of that one. Some people implement kill switches with multi-sigs and have multiple people required to basically implement the kill switch. Audits are really great as well. They could be thought of as kind of like a security-focused peer review for your smart contracts and code by an external company, right? So they literally go through your code line by line and try to find issues with it, right? So they're great for catching things that you or your team may have missed. And these companies spent 100% of their time focusing on smart contract security. So they're very good at their jobs, and they're great at finding potential vulnerabilities. However, they won't always catch everything. There have been cases where very notable smart contract audit companies will audit some protocol and give it the green light, and then a week later it gets exploited, right? So they don't always catch anything. And in the end, these smart contract auditing companies are not going to be the ones liable in the event of an issue occurring, right? It's going to be you that's liable for your protocol. So just be mindful and don't think of them as a silver bullet solution. Think of them as a way to implement a solid defense in-depth solution for building secure Web3 systems. Another great thing to do is be aware of the latest happenings in the Web3 security world, right? Having an up-to-date awareness of exploits and hacks as they occur keeps you in the right mindset, and make sure you don't make the same mistakes when you build your own Web3 systems and protocols. So there are some great resources out there. I've listed a couple of my favorites here. I can highly recommend RectHQ. You can find it at RectHQ on Twitter, or rect.news is their site. They're awesome. Highly recommend them. So just to summarize, when working with these Web3 systems, you'll likely use smart contracts as the thing that controls the logic of the system. And these smart contracts are immutable programs. They can't be changed. Their code is often associated. It's often open, and the transactions can generally be seen by anyone, right? And these are immutable programs that often control the movement of funds. So security is an extremely important aspect when building these systems. But if we have an awareness of the currently known vulnerabilities, and we learn from the exploits of the past, if we follow best practices, if we keep an open mind and keep up with the latest security-focused conversations in the community, we can reduce the risk of vulnerabilities from occurring, which will help to avoid really bad situations such as the loss of user funds. Right, so by having secure Web3 systems and doing all we can to avoid exploits and vulnerabilities, we can really help to mature Web3 as an industry and help to accelerate its adoption as well. Thank you very much for listening to my talk.
This talk is sponsored by
developers in
This talk is sponsored by Polygon. Polygon is the leading platform for Ethereum scaling and infrastructure development. Its growing suite of products enables developers to build scalable, user-friendly dApps with low transaction fees without ever sacrificing on security. Learn more at polygon.technology.
Hey guys, I'm Preeti Kasreddy, and this is the closing keynote for Web3Con. I'm super excited to be here. I've been involved in Developer DAO for a few months now and just continue to be amazed by the amount of excitement, energy, and value that the community is creating. And so, yeah, I'm excited to see where Developer DAO goes in the future. For today's talk, though, I want to focus on a specific topic related to getting more developers in the ecosystem, getting more developers into Web3. That's been an area that personally I've been focused on for the past year. And I know that Developer DAO is also focused on that. They put out a lot of resources for developers to come in and learn Web3. And it's a really welcoming community. But I want to kind of talk about what more we can do to get more developers in the space and why we need more developers as well. So with that aside, I'm going to get started. Just give me one sec. Okay, so hopefully you can see my screen, and I don't really do that many Loom videos, so this is an interesting way of giving a talk, but you know, that's the world we live in today, in a digital world. So let's just get started. So who am I, right? My name is Preeti Kasreddy. I'm currently the founder of dAppCamp. So dAppCamp, what we're doing is we created a boot camp, like a coding boot camp, except it's for teaching people Web3 development. So we don't teach people how to code. We only accept existing software engineers who have demonstrated a certain caliber of technical skills. And we take those existing really strong software engineers and then we train them on Web3 development. Our course is 3 weeks long, but really I would say it's more like 6 weeks long because we do give students 3 weeks of homework beforehand and then we help them afterwards, giving them resources to do. It's kind of like 3 weeks is when we're meeting live and doing all the cool stuff. And then it's like a lifelong journey where we're with them as they're coming into Web3. So this is our website. And yeah, if you're interested in becoming a Web3 developer and you want a more like curated approach, a lot more one-on-one interactions, and you're willing to pay for that, feel free to sign up for the wait list and we'll be in touch when we open our next cohort. So with that aside, really, one of the biggest reasons I started dAppCamp was because I had previously started a crypto company. Oh, I kind of skipped my background. So previously, I had started a crypto company myself. So at the end of 2017, early 2018, I founded my own crypto startup called True Story. And basically, you could consider us a social networking app on the blockchain. And we were really trying to use token incentives to see if we can create a mechanism to curate the truth on the internet. We spent 2 years building it. It was super fun. I learned a ton. We all had a lot of fun building it. Ultimately, we realized that we felt like we were a little bit too early to market. And something like this will exist maybe, in a couple of years from now or even 5 years from now. But we felt like there's still so much core infrastructure that needed to be built in Web3 that building a social network before all of that existed felt like putting the cart before the horse. So we shut the company down in early 2020, and I've kind of been doing other stuff after that. I took a break from crypto for a while. And then when I came back into the space, one of the biggest things I felt like was missing was there was a lot of new people that were coming into the space because of things like DeFi and NFTs and stuff like that. So it brought a lot of mainstream interest into the space, but it still felt like the number of developers was lacking. Like there were so many hard problems to be solved in crypto and not enough developers solving it. It was the same people from 2017 that are still some of the that were still some of the top developers in 2020 and 2021. And I felt like that needed to change. We need to bring more developers into the space to be able to explore the problem space and figure out how can we tackle some of these like really big issues that we have. And, you know, crypto and Web3 gets a lot of criticism, and some of it is, you know, you can kind of just brush it off because it's clear that the person hasn't really done much research or thinking around the topic. But some of it, you know, there's some you can actually justify, and you're like, I can see this person's point of view. And oftentimes the argument is like, just give us more time. Like, this is so early. We need more time to get to that solution. But I think we can compress the amount of time that we spend getting to the ultimate vision for Web3 if we have more developers, if we have more people and talent building in the space. That was one of the reasons I started DAppCamp. I know that, like, when I tried to get into Ethereum development, it was really, really, really difficult. That was back in 2017. And the way I learned was I would just look through ICO projects and their smart contracts and try to see how they worked. Ethereum's documentation was kind of existent, but it wasn't that great. There was not that great tooling. Truffle existed, but really that was kind of the gist of it. Open Zeppelin existed, but compared to what exists now for a developer in Web3, like, there was not much. And we've made a lot of progress since then. And so I felt like this was a good time to get more mainstream developers into Web3. And that was one of the reasons I started DAppCamp. Previous to that, I was also a software engineer at Coinbase. And prior to that, I was a partner at A16Z way back in 2013 to 2015. And then before that, I worked at Goldman Sachs as an analyst. So I kind of been around the finance tech world in many different ways, as a banker, as a venture capitalist, then as a software engineer, and then as a founder. And now I'm a founder again, but mostly teaching developers. So with that aside, I truly believe that we need more developers in Web3. And there's just so much opportunity for developers in the space and to create really, really cool things. Some of the opportunities that I think exist are the obvious ones that we've probably all heard of. One of the biggest things is that with Web3 and crypto, we can kind of rebuild our entire financial system. I think 2020 taught us how weak and fragile and unstable our financial system is, and how fake is probably the right word, how fake it is, how it's really propped up by these central banks that have unlimited power to print money and kind of change rules whenever they want. And consumers are kind of at the mercy of whatever they decide to do. And crypto, really, the ethos of crypto is that we want to rebuild trust in the financial system, right? Let's create a system that's more open. Let's create a system that's more transparent. Let's create a system that allows people to transact in a way that doesn't rely on a couple people making certain big decisions. So can we create an open, decentralized global financial system is still very much an unanswered question in Web3. I would say we have some early proof of concepts that show that we can, but we don't have mainstream adoption yet. And I think developers who come into the space can really help shape that future, because they can come in and they can solve some of the hard problems, whether it's like more on the protocol layer or on the UX layer. I think we need developers working all across the stack to really rebuild that financial system. The other opportunity I think that exists is we can basically try to build the internet from scratch again. And maybe not from scratch, but at least try to rebuild some of the core things to be a lot more open. And so Chris Dixon is an example of someone who's really good at kind of laying out the argument for why we need more open protocols in Web3. And I believe that he's very right. Like, you know, Web 1.0, as we call it, had a lot more open standards. That's how we developed various types of protocols that we use today to this day. And Web 2 suddenly kind of centralized a lot of the services and the internet that we use today. Like, when we think about the internet, like for most people, it's Google and Facebook, which is a centralized company. They're not open protocols. They're not things that other developers can build on. They're not things that provide APIs and transparency into how they're doing things. They have full control over the protocols and the systems, and hence full control of the users that use them. And so it's an opportunity for developers who are coming into the space to really rethink how we can build an internet that's more open, that's more transparent and public and fair, etc. The other big opportunity for developers is, especially if you're coming from a developing economy or a country that's authoritarian or whatever, where you might not have access to the financial infrastructure that we have in the US or any developing country. And so getting access to a permissionless financial system is a huge deal. I think a lot of people, that opens up so many opportunities for people who are in these countries who don't have access to that. Without financial access, what do you have, right? You don't have rights, basically, because if you don't have the ability to transact, you don't have the ability to actually exercise your rights as a citizen, and that diminishes you as a person, right? Like if you don't have the ability to exercise your rights, that's very disempowering. And I think crypto has the opportunity to create a permissionless digital economy that anyone can participate in and have a voice in, and have the ability to do things in and transact and et cetera, et cetera. So I think developers who might be interested in building that part of the crypto stack, there's an opportunity there as well. And overall, like the whole ethos of crypto is, how can we move power from the center to the edges, right? Right now, we're starting to see the downsides of too much centralization. That's not to say that we need to live in a completely decentralized world. I think that could also be inefficient in a lot of ways. Centralization sometimes makes things a lot more efficient. But this pendulum has swung way too far on the efficiency side, where we've kind of given up things like freedom, the ability for the individual to be empowered. And instead, we've given the power away to these centralized organizations. And I think crypto allows you as a developer to come in and make a big difference in helping the pendulum swing slightly the other way, so that we can give more power to the people and not to centralized companies who in the long run end up having skewed incentives because they're trying to keep the amount of power that they've accumulated. And the other opportunity for developers is that you get to tinker with really cutting edge technology. Like, that's one of the reasons I got into the space. When I was reading about Bitcoin, when I was reading about Ethereum back in 2015, 2016, 2017, it was like there were so few people who understood it, which is one reason that made it exciting, because I was like, what is this thing that like very few people understand, but it seems very important. Like at the time, I really couldn't figure out like why. I just had a feeling that this was going to be important, but I was like, this is something that I feel like is going to be important. I think I should spend more time on it. And the more time I spent on it, I was like, this is really cool. Like, this is so new. It's novel. It's like a blank canvas for a developer to come in and make a difference, to be able to think about innovative ways of doing things, new ideas. And right now the market is so hyped, for better or worse, that like there's so many, if you have an idea, it's likely that you can go out and build it and get funding for it. So take advantage of that opportunity, right? Or join an existing protocol that you're really excited by and contribute to that and provide interesting ideas there. Like really, when I say crypto is a blank canvas, it truly is, even though it might feel like, you're too late to the game. I think from a technical standpoint, we maybe have covered like 5% of the ground. There's so many problems, interesting problems that developers can tackle. And like some of them, there's like no one looking at them. So you might be the first person looking at certain problems in the space. And that's exciting to me, at least to me, that's exciting. It's exciting when you can be more on the cutting edge, doing things that other people are going to catch up to you in like 5 years. So that kind of sums up some of the opportunities that I believe exist in Web3 for developers. There's challenges though, right? Obviously, I've been kind of talking about how there's not enough developers and a lot of problems. So one of the biggest challenges of Web3 is, can we get more people interested in the space? Can we get more developers? Can we get more designers? Can we get more product managers? Can we get more operations people, community managers? Can we get talent into the space to really do the things that we want to do? And especially like high quality talent, right? So that's obviously a challenge. The other interesting challenge that I'm going to spend a little bit more time on is criticisms and misunderstandings of Web3, because I know that we face it even at DAppCamp, where developers, sometimes they come in and then, they're excited by the tech, but then they hear the news or some influencer or something say XYZ about Web3, and then they start having all these doubts, and then they get scared, and they're like, is this worth, it seems so risky, like should I risk my entire career to come into the space? So it certainly does affect how many developers come into the space when you see all of this public criticism being created about Web3. And some of it is being created by really, really reputable people. These are not like, some of it, yeah, you can just kind of ignore and shrug off because you're like, this person clearly is a troll and why would I care what he has to say? But other times there's actually really reputable people saying this criticism, and I've noticed that it does sometimes make developers take a step back and be like, maybe I should stick to Web2 until this thing is a little bit more proven out. So I do want to focus a little bit on that. And I created this open source repo, which you can see here, and anyone could contribute to it. I figured this is the best way to kind of start putting together some of the criticisms of Web3 and then putting together strong counter arguments to it. So, for example, proof of work wastes a lot of energy, right? This is a very common criticism that you will hear over and over and over and over and over again in Web3, and every developer will come ask me or our DAppCamp teachers, like, what do you think of this? Is this going to ruin the entire planet? And like, anytime someone kind of brings up that criticism, it kind of tells me that they haven't done enough research and digging. So what I did was I went in and pulled out very strong counter arguments to that criticism. For example, the fact that Bitcoin uses energy that otherwise would go to waste. And here's a source that kind of shows that is actually true. So for example, in Shenwan, like they massively overbuilt the hydroelectric power in the last decade, and a lot of Bitcoin miners actually use that hydropower to do mining. So another thing is the fact that Bitcoin mining is a net benefit for the energy sector, and here's a source that kind of explains why that is. Basically, the idea being here that with Bitcoin mining, because it's not like necessarily like a hospital or a factory that needs to be on all the time, they have the ability to do sort of a variable, they have the ability to have like a controllable load where they can dial their energy needs up and down. And so they can use more better sources of energy to actually power the mining equipment compared to other types of use cases for energy. And then, I kind of list out other counter arguments, and I'd encourage you to go through this yourself if you're interested. And please, if you find other good counter arguments, I'd love for you to make a PR or an issue that kind of adds to this, and I'll add it to the doc. And then, there's been other very strong criticism of Web3. For example, most recently, Moxie put out a really thorough blog post about how Web3 has a lot of centralized services like OpenSea. And that's a valid criticism, right? Like we have NFTs, but then we have OpenSea, which is kind of serving as the gatekeeper to these NFTs for most people. And here's a list of counter arguments that kind of show that actually, when you truly think about it, this is not actually as valid of a criticism as it seems on the surface. Because, for example, in Web 2, with Facebook, right? Like you use Facebook and the data is owned by Facebook. With OpenSea, you use OpenSea, but the data is owned by the Ethereum blockchain. So you as a user are still owning the underlying data. So the network effects still accrue to Ethereum, and they accrue to OpenSea a little bit because they have obviously users who are coming to the platform and they're able to accrue those network effects. But the data network effects still accrue to the blockchain. You still own your data. You can still port your data over, and the network effects are not necessarily accruing with OpenSea as much as it is with the public blockchain. And then, I kind of go into that argument a little bit further and explain it. So definitely take a look at that. And then the other thing is, there's going to be decentralized alternatives of OpenSea. I don't think that's a strong necessarily counter argument against what exists today, because that has yet to be seen. But I do believe they'll exist. So at least people will have a choice to use a decentralized alternative if they want to. There's other criticisms here that I've listed, like most people don't want to own their keys. This is another very common criticism that people will hear. And especially as a developer, like when you're building Web3 apps, you have to go through so much pain to do key management, signing, and all that. And like, it just makes it much harder to build a good UX for your users. And so sometimes when you're developing applications and you're having to do key management and stuff, like you might be wondering like why would users want to go through all this pain? Why do users want to sign every transaction? It sounds like a lot of work for users. And so like from a UX perspective, it might not be as good of an experience today, but I believe that will get better. But really the counter argument to this is that the option to owning your keys is a blessing for some people. Like some people live in countries or with authoritarian governments or and things like that, where not having the ability to hold your keys means they have no financial freedom. So the ability to hold your keys in a non-custodial way is very, very valuable to some people. It might not be valuable to everyone if especially they live in a country that's more free, but not everyone's like that. And then secondly, the UX sucks today, but I believe that the UX will get better over time. We're already seeing really innovative solutions get created with things like social recovery, where instead of having to maintain this key and the seed phrase, and the seed phrase really is annoying to store, people are coming up with ways to be able to recover your keys through friends and family that you give a part of the key to, and then you need 2 of 3 of those friends and family members to approve to be able to sign a transaction or regenerate a new key if you lose it and things like that. So I think even that argument, even that criticism, we can find really strong counter arguments to it. The other often argument that I'll see against, or criticism I'll see against crypto, is that it's a solution in search of a problem. And I think if you said that 5 years ago, I would have said, yeah, that's a valid criticism, because there's really not much utility. Like, people haven't proven the utility of it yet. But today, I think with everything that's happened with 2020 and more recently, things like the Ukraine-Russia situation and Canada last couple weeks ago, like, you're starting to see the importance of things like non-custodial wallets, for example, the ability to have not rely on your government for access to the financial system. That is becoming more and more obvious to people as time goes, and as these existing entrenched financial and economic and political systems, as the curtains get pulled back on them and we start to see how, bad and poorly run and misaligned the incentives are, we're really starting to see that crypto could be our way out. And I think if you asked people 5 years ago, like I said, things were not, think the economy was doing well, like there was no 2020 back then. So it's hard to kind of conceptualize how crypto could be useful. But now we're starting to see that there is really a lot of value to it. The ability to own your keys, et cetera, and have non-custodial wallets. And going, the other argument for this is that Web 2 monopolies are a real problem. We all feel that things like Facebook, Instagram, Google, Apple, we can feel that something is wrong, like something is off. The incentives are not proper. They support the company instead of the users more. And users are kind of almost oblivious to what they're giving up to use these services. And I think as a developer, you can really come in the space and help, like I said, rebuild how we think about internet protocols and internet products and internet services so that data is accruing to public blockchains and not to private companies. There's other criticisms that I kind of tackle in this thing, like cryptocurrencies as used for illicit activities. That's an easy one to debunk because when you actually look at the data, it's well below 1%. And in fact, cash is actually preferred method of doing illicit activity because Bitcoin is a lot more traceable and you leave a paper trail if you use Bitcoin compared to cash, and so forth. And then, I had something about NFTs because I heard this one recently about how NFTs offer no intellectual property protection. And again, a few counter arguments to that kind of show that they actually do, or they will in the future. And as NFTs evolve, we'll start to create standards around how we can create almost like readable rights on the blockchain with NFTs that exist on the blockchain, so anyone can verify that you have the right to this particular NFT. Long story short, there's a lot of criticisms in Web3, and like this is probably maybe 10% of what I've heard and seen in the space over the last 6-7 years. There's a whole list of criticisms that I had written down initially before I created this original doc. And it's just the nature of how Web3 works. Like and any new technology works, right? Like if you're going to come into the space and become a builder in Web3, you have to just acknowledge that it's a new thing and people are going to be skeptical. People are going to be scared. People don't like change generally. So they're going to find ways to fight back. But if you just spend, 3 months, 6 months, just really digging in, going deep, understanding the premise behind Web3, why it exists, I think you can come out the other end with a really strong belief that there is some value being created here. It's not just all hype and money and tokens and going to the moon and things like that. Granted, there's a lot of that, and unfortunately, that is a good thing in the sense that it does bring a lot of people and eyes to the space. But it's a bad thing in the sense that it kind of leaves a bad taste in certain people's mouth because they're like, this is all that this is about. Like it's price go up and stuff like that. But I think as a technologist, you should be looking deeper below that surface and really looking at the actual technology and figuring out what you can build there, what you can contribute there to make all of these things a reality. And there's going to be more and more criticisms that come in. And if you continue to get swayed by them, then you're not going to last that long in Web3. I really think one thing that Web3 forces you to do, as whether you're a developer or just not a developer even, is that it forces you to critically think. It forces you to understand things, go a layer deeper than what you knew before. It forces you to peel back and understand how certain systems work, how certain organizations work, how certain countries work, etc. And And only then do you gain an appreciation for Web3. Until that happens, like, you're going to continue to get swayed. So I guess the advice that I have for new developers is, there's going to be criticisms, and we should continue to tackle them one by one. And as Web3 developers, it's our job to be able to have strong debate and strong counter arguments to the arguments the criticisms that come up. But as someone new to the space, it's also your job to be able to critically think and not just read some Medium blog post or some New York Times post or some Twitter thread that posts a bunch of FUD, and you're like, oh my God, like, crypto's a scam and this is not worth my time. Like, if you're that easily swayed, then that's not a good thing. So I'd encourage you to just, every time you hear a criticism, don't ignore it, because I think it's important in your own head to create counter arguments for it so that your belief in Web3 continues to harden. And if there's certain things where you're like, oh, fuck, like, this person said something and I don't actually have a strong counter argument to it, which has happened to me in the past. Like, there's been a few times when I was hiring for True Story and people would ask me certain things, and I was like, wow, you put me on the spot, because I didn't actually think about that criticism. That's a valid criticism. So I think it's important to look at criticism when it gets created, when people put it out, and come up with and really deeply think about what that person is trying to say and whether you believe Web3, whether you believe you have a strong counter argument to that, basically. So I kind of rambled on for 30 minutes about the opportunities for Web3, as well as some of the challenges for Web3, specifically getting more developers and not being tripped up by all the criticisms that come that get created in the space. So I'm going to just close off here with some parting thoughts. Actually, one more thing. There's one more challenge I did want to talk about, which is complacency. I think sometimes when people come into Web3 without a strong understanding of why we're doing the things we're doing, they can take shortcuts. And it's a blurry line, because at one point, and on one end, you want to ship things faster and you want to get users and you want to make a lot of money or whatever it is. But I think it's also important to think about whether that shortcut really achieves the goal, end goal of why you're using Web3, why you're building on Web3 in the first place. So I'm trying to think of a good example, like we've kind of, for example, as an industry standardized on MetaMask. I have nothing against MetaMask. I think MetaMask has done a lot for Web3, but the fact that we still don't have a better wallet that most people are using is, I think, a little bit of a factor of complacency. And as developers, I think we should be thinking about how we can kind of fix some of the shortcuts that we've taken, and how can we build better technology and not get complacent, not end back where we started with Web 2 by getting complacent, taking shortcuts, creating choke points of centralization and so forth. So I would say that's an interesting challenge that I've noticed more recently, where certain teams, in the interest of trying to get a product out as quickly as possible, they take shortcuts. And again, this is a very blurry gray line, because like it's important to ship fast and get feedback fast, but it's also important to not let go of the fundamental principles that Web3 offers. And I think as a developer, really think about that when you're building things, and think about, okay, I'm taking this shortcut here. Why am I taking this shortcut? And am I going to fix this shortcut once I prove and validate the market for this? And rather than like keeping that shortcut forever. So it's just a little point I wanted to make. So yeah, that's kind of just what I wanted to convey, that we have a lot of opportunities, a lot of challenges in Web3, and what Developer DAO is doing is super, super important. And I can't express how cool it is to see a community of just developers who are posting really interesting content, whether that's articles, blog posts, tweets, resources, help, answering questions. Like the amount of intel that you can get by joining a community like Developer DAO as a developer is off the charts. And I think Developer DAO is going to make a huge dent in bringing more developers in the space. Now I'm like, okay, how can we 10x that? How can we, bring all the developers, as many developers as there are in Google, into Web3 by next year or something? Like, how can we be more ambitious and get more developers in the space? Because the more developers we have, the more innovation we have. So I want you to think about that. And if you have developer friends, how can you encourage them to want to come into the space? Or maybe one best way to do it is just to build yourself and show what you're building, show how cool it is to be shipping the things that you're shipping, and then other people will see what you're doing and be like, oh, that looks interesting. Why am I working on this boring Web 2 thing? I'm just going to do that Web 3 thing. So think about it. Think about how to get more developers in the space, how to get more of your friends in the space, and how you as a developer can also be contributing more to the development of Web3, whether that's existing protocols or new projects. Build. So just keep building, and hopefully you are enjoying while you're building as well. So that kind of concludes my talk. Hopefully it provided some value. I kind of know I've rambled here and there and covered a lot of different things. So hopefully I didn't get anyone lost. And if you have any questions, you could always reach out to me on my Twitter. I am _Preeti. I'm also part of the Developer DAO Discord. I'm an advisor, so reach out to me anytime in the Discord as well. I'd love to connect. And hopefully you have a great rest of your day.